Three lines on the shirt. I absolute cinema. Last night I was up until like I think 4 a.m. Maybe longer actually. Maybe like 5 a.m. watching the England versus Mexico game. Peak, but that is the best I've ever seen England play. Well, I mean, in my lifespan, right? And I've seen people saying like that's the best they've played since like 1966, right? Like honestly, it is quite incredible. Like for once, it actually feels like we're a team, you know? Because like when I watch these cups, yes, you have the players, right? Like the individual players. You have your Messi's, your Ronaldo's, your Haaland's, your Kane's, right? But the teamwork makes a dream work, and I think England, you know, just show that so well in this game, and even with sorry, and I see it as well with like France as well. Like I feel like France is a really strong team with Mbappe, Olise, Dembele, and like the way that they, I mean like. And more like specifically those two players, the way that they like kind of triangulate towards the goal. Like you just see these things where the players actually play together as a team, and it's so cool. It's so cool, and like it's why like these super teams like I don't know, like was it like Messi, Mbappe, Neymar, like those kind of things don't really work out because like you could just throw I don't know like talent into a pool and expect it to work. Like no, like you need to have actual teamwork because it's a team game, you know, and then you have people play to their strengths and people can play to other people's strengths as well, like to the teammates' strengths, and like you know they can support each other. So like when you have like Anthony Gordon, right, coming up and pass it like crossing it to Kane, I think that was against what was it? Whatever team he played last, Brazil. That's right. Like those assists from Gordon were amazing, and like he said himself, like. You know, the reason he was confident to do that was because he saw Kane there, right? He saw Kane there and he knew that he would get it in. And he did. And then in this one, you know, you had, again, Gordon was, you know, popped off, did great. You had Bellingham, did incredible the whole way through. He played to the very end from start to finish. And like by the end, like, he like collapsed on the floor. And, like, you could see he was exhausted. Everyone was exhausted. It was a crazy game. Mexico also played incredibly well. You know, didn't have like a repeat of Paraguay. Like, the ref was actually good as well. Really good. England had a red card and still managed to, you know, to defend and score a goal with Harry Kane's penalty. Yeah, just perfect. Beautiful. Anyway, just had to bring that up because that is just too awesome. So today I'm going to be looking at this. I think. Am I? Yeah. So this is Ante. It is an not esoteric. It is it's a programming language that's made by someone who's passionate about programming languages, if that makes sense. I mean, I'd assume that everyone is who makes a programming language, but I mean, like, it's like a personal, like, you know, it's like someone's passion project, basically, as opposed to, like, a proper, like, I don't know, like, C#, like, I can't even talk anyway, so... This is Ante. The guy who made it is here in this Discord server. You can see here is a channel. I think that's how I found it. And since there's a whole website with a blog as well, I thought I'd give it a look and check it out. Oh, there's scrolls. I didn't even realize the first time. Okay, so Ante is a low-level functional language. It's very interesting. Because a lot of functional languages are obviously not that low-level. And that's kind of been my frustration with them a lot of the time. And I don't hate functional programming. It's just a bit like, I find the ergonomics to be a bit, you know, not great at times. But generally speaking, I don't mind it. Probably my biggest issue with functional programming is, well, first of all, debuggability, but you can't get around that. But also just recursion is such a pain in the ass. Anyway, so Ante as an active development, it's for exploring algebraic effects, safe shared mutability, and other novel features. So it's kind of like an experimental language in that sense, like Haskell was, right? I mean, I guess it still is, but like it's kind of also become a bit more mainstream for some reason. Probably because it has so many cool features. In particular, algebraic effects is something that I haven't looked too much into in my time. Like a proper like effect system. But to my understanding, they work somewhat similar to exceptions, like where like you'd say that this throws this exception and this throws this exception. If you have an effect, it's saying that you can, like this thing may use this effect. Like I may use the IO effect, and then therefore I might get some IO exceptions or whatever as a result, right? So that kind of thing. Because a pure function is one which doesn't error, right? So effects would be one which can error, and I guess you catch it is, well, I mean, there are probably different ways that you can handle it with an effect handler, but exceptions come to mind from what I've seen so far. There are also besides the language tour, there is also a article on why algebraic effects. So this is long. So I think I want to have a read of this. I mean, should I? No. Okay, so I want to read the spec first of the language. I mean, this is also incredibly long, but I'll give that a read. This is one page. Yeah, it is one page. Okay. I'll give this a read. Maybe skip it because it's very long, and then I'll have a look at this afterwards, hopefully, unless I'm worn out by reading it, because again, it's very long. And then I also want to have a look at this, because this is quite interesting. And then there's also these ideas, which are also interesting. So yeah, let's have a look. So Ante is a low-level functional language. Hold on, let me just make sure my mic is actually the right one. Yeah, it is. So Ante is an... Whoops. Okay, so opt-out move semantics. So move semantics, I think of Rust and C++, obviously. What's an opt-out? So move value x equals this. So this is a... I can't highlight, it's kind of annoying. This is a function, sorry. I don't know why I'm so lost for words right now. So move value will move a value and equals this, so I guess it just, like Rust, it just automatically just drops it because it takes ownership of it. So I'm guessing it's a similar model to Rust then, in terms of borrowing and passing on ownership by default. Most types are not shared and use move semantics by default. I see. So move value vec, okay, move value vec, error is already moved. So like Rust, right? Makes sense. Now I do have an issue with this, to be fair, which is that like this code is identical, and like yet this one errors and this one doesn't, and I find that a bit like it's not ideal. Why can't I zoom in? I can. To be fair, I didn't need to that much anyway. But yeah, it's not ideal how like code that looks the same can just behave completely differently, in which one can error because one is really moved. Now, I mean, the good thing is that the compiler will catch this no matter what, because borrow checking, unless it doesn't borrow check, but hopefully it does. But yeah, that's just something I've observed that I'm kind of not super keen on. But at the same time, I still do think that moves by default is a good way to go, and then you can also borrow check it, so that's just good. But shared types can be defined, which enable cleaner code and a gentler learning curve. So shared type expression equals an int, a var with a name string. That's interesting. What's var? What is var? Int I32. Huh? Add expr expr. Oh, it's a it's an enum. Okay, so we have a sum type, right? So expression equals int I32 var string add expression function. Interestingly, this has a name, this doesn't, and that's how you add names, I guess. No explicit boxing since expr is shared. Ah, cool. So foo equals expression.var foo, move value foo, move value foo. That's fine. So, okay, this can create issues though, because then it's like it's type dependent. So this is fine, but this isn't, and like there's no like now you kind of created a bigger issue, because now these behave differently, these behave the same, and I literally have no way to tell, besides checking like the type information on whether they're shared or not. I have no way to tell which is yes and which isn't. So that's kind of funky, but I mean I see why you would do it, having it opt out. You know, like it can be advantageous, I guess, for cleaner code, but I don't know. I feel like you would I feel like you should use either one or the other in that case. But okay. The cool thing though is you don't need boxing here. That is quite cool. And I wonder how that can be used generally. Okay. Traits via implicits. So abilities in Ante are just sugar for types holding closure values. So what does that mean? Oh, it's like it's a trait. So you need to have the ability to add. That's interesting. The ability add. Ooh. Okay, the reason this is interesting is not just because it's a different name. It's because it gives your things a different naming scheme. Like, if you say that an integer has the addable trait, right? Has the trait addable. You have to say addable because you're able to add it, and then its trait is that it is addable. Like at least as far as English goes. With ability, you can say int has the ability add, right? The ability to add, to perform add, or int has the add ability. You see, like that makes sense, and it's much more concise. So that is actually quite interesting. And then you have a function here plus, I can't highlight, sorry. I have a function here plus, which is an operator Haskell style with a fn function tt to t. That's the type, right? I'm not a huge fan of types being lowercase. I will say that, but maybe it has some benefits for like higher order types if the language supports that. I don't know. So let me actually put that in my ideas box down here. So abilities over traits. Right, so inspiration is anti-lang. For the love of God, holy lag. Yeah. I need to sort out my Linux thing, because I don't like how special workspaces go over it. Like, I wanted to switch to the special workspace. Like, instead, like, here I'm on my special one. If I now switch back to my first one, second, first, like, you can see that nothing changes, even though in the top left, my workspace is switching. But then if I close it, then it does switch. But, like, I want to just switch to it, not, like, have it be an overlay. But anyway, abilities over traits. Having an ability keyword instead of a trait or like class keyword for interfaces, or well, I guess like really interface keyword for interfaces allows for more succinct how do you say succinct? Succinct? No, what? Succinct. Yeah, there you go. For more succinct interface names. For example, you would say, you would naturally want to say foo. Well, let's do int. Or integer is has the addable trait, or integer derives from the addable interface. But it is also natural to say integer has the add ability, or integer has the ability to add, right? Therefore, the key difference is shorter names. Yeah, just shorter, simpler interface names, titles even. you can even see that addable has the able suffix, which is literally linked to the word ability. So like it just makes sense. Very cool. Since they are just values, we can like that's an issue that I've never really thought about. So it's like it's never been on my mind how like some languages will have it called trait. Like Rust has it called trait, but the trait is called add. Like that's always been weird to me. When I do traits, I prefer to, or interfaces, whatever, in different languages, I prefer to make it read a bit more Englishy by having it be called addable or like printable or something like that. But calling it ability is a lot cooler because it's more succinct. Plus, you say like int has the ability to add, right? Like int is addable. Like yeah, I mean like it's the same thing. Like addable or ability to add. Like it just reads like that. So yeah, that's cool. Since they're just values, we can create them in normal constructor expressions, and no global coherence or orphan restrictions are required. Okay, orphan restrictions are terrible. The orphan rule, I hate it in Rust. So this is already speaking to me. Since they are just values, okay, what's they? And what's them? Abilities. Implicit. Okay, so when it says create, I don't know actually. What's this about? Implicit ord I32 descending equals ord I32. Is ord an ability? I'm going to assume that it is an ability, but I can't tell. Equals ord I32. So this is a function with compare, or is it a type? A, B, ordering from int B minus A. Okay. Yeah, I don't know what that means, but we'll find out later. Ability values can be defined locally, and closures can capture data, making implementing them on intern types much easier. So implicit, display interned, CTX, intern CTX. Defined locally, and closures can capture data, making implementing them on intern types much easier. Display my intern type with display intern equals. Use this on the closure environment, which is this, right? Yeah, okay. I need to see more examples of that because I don't really understand. So let me just say here as well. Ability instead of trait is such a cool idea. Simply because ability reads is more succinct than trait addable. Just reads weird. Give credit where credit is due. Effects. Also, I feel like the ability keyword just sounds natural for an effects-full language, like an effect-based language as well. I mean, not based, but like effect, like a language with effects. Because like you say, this has the effect to perform I/O, or like to produce I/O effects, right? Likewise, it has the ability to perform I/O. It also seems quite fitting with the theme of effects, right? Like, foo has the ability of I/O, which can produce I/O effects or whatever. Yeah. We'll keep reading and see what we get from that. So effects are just abilities with resume function. Oh, so they actually are abilities with resume functions, enabling effect handlers. So ability throw, throw resume function error. Wow. With resume functions enabling effect handlers. So let's see. And capabilities. Where's resume? Throw, resume function error to never. Okay, I don't understand what that means either, but we'll see. And capabilities are just ability values, which are often passed as implicits. Oh, wait, so effects aren't even like called effects, they're just called abilities. That's kind of cool as well, actually. Ooh, that's very interesting. That's very interesting. Because usually when you create a custom exception in C++ or Java, you would derive from the exception class, right, or the checked or unchecked exception class, or checked exception. I don't know, whichever one, right? You would, or like an IO exception, you would derive from it. Now, yeah. So like in that sense, you're kind of deriving from an interface. So, I mean, exceptions themselves they're built into the language, but like it's kind of interesting how that's done. Very interesting. And capabilities are just ability values, which are often passed as implicits. So sign up, name string, email, throw, validation error, throw IO error, IO. Interesting. User equals, okay. Unlike monads, capabilities are trivial to combine, they are just implicit parameters. So it requires throw IO error and IO. Okay, well you have throw IO error and you have IO, so that's fine. So config equals this. And they can be passed explicitly if desired or required. So validate, name, email, and T. So what is T actually doing here? There's no example there. Throw validation error. Pass as implicits. So like you define it yourself. So you can define your own handler. Oh, okay. No, that makes sense. Interesting. So you can have an explicit handler if you want to. Yeah, I mean, like in C++, you could like pass a function, I suppose, or like pass your own derived class. So yeah, yeah. I mean, it's just like a pattern that I haven't really seen that much, but that's cool. Have it being this simple. Throw IO error, and then IO is an ability as well. So you have the ability to throw IO error, but you have also the ability to do IO. What I wonder is why doing IO doesn't also give you the ability to throw an IO error. I mean, maybe they're mutual. They're not, like mutual things, but like one doesn't necessitate the other. But just in general. Anyway, sign up. Okay, no function, coloring problem. Mapvec trivially works with exceptions, async, etc. Any capabilities required by F are captured in its closure. No function coloring problem. Mapvec trivially works with exceptions, async, etc. So this works with anything. They're captured in the closure. Okay, again, I've seen an example of that. Even more interesting, how effects are also just abilities with resume. Stage mutability. So var vec equals vec of this. Ref1 equals mutable vec. So create a temporary mutable reference to vec. Right. So mute takes a mutable reference in this case. Ooh, hold on, mutable. So this language does have mutability. I wonder how that works with the functional syntax. I'm quite curious. Okay, it is safe to call vec.push with shared mutable references. Retrieving a reference to an element is also possible, but we can't use another mutable references. So I use others to get the same value was active. Ref1.get 0. Again, you see an example of that. What I'm wondering is why you don't need to declare vec as shared in order to do this. I mean, is it mutable reference? Yeah, but it's a mutable reference, and you have multiple. I don't know. Okay. And generators. Generators are implemented via effects. So ability, emit, lem, emit, resume. Again, I don't know what resume does. One advantage of generators is that they are easier to write than iterators. We'll supply the emit A value, but the caller needs to provide a capability for emit B. Okay. From ABC, return this. Parse CSV. Oh, we got piping, cool. Lines, text, Skip one, map function line, split line, vec of. So that's using map, right? So map takes a stream, a function, and then emit B. Why do you have emit? Oh, because it's function A to B. Is B a class then? But then why does it emit a type? Very confused about that. Yeah, very confused about that. Unless this isn't a return type. Unless this is like the value that we're passing here. Map. Map here only takes one argument, but here it says it has 2 arguments. Well, 3 if you include this one. So like, what's going on with that as well? Unless it's because we're piping. Yeah, maybe I'm just misremembering how piping works. So piping, you would pipe this result into this, into what I assume is its first argument, not its second one. So that's that, and then you pipe that into here. So this is the stream. Okay, anyway, Ante claims to help bridge the gap between low-level languages like C++ and Rust and high-level garbage-collected languages like Java, OCaml, and Haskell. Ante aims to make developing programs easier by allowing patches like shapeability. Okay. So shapeability is a common cause of bugs. In Ante, not only is it safe, it is zero cost. Okay. The type system will prevent unsafe operations on mutably shared references at compile time. Secure. It has capability-based security. If you don't pass an IO object to a function, it can't use it. Okay, it can't even use external linked code without being allowed to do so. Abilities combine traits and an effect system and provide great code reuse. They are easier to use when compared to monads and provide clear type errors when things are not expected. I didn't get the monad thing. Where was it? They're trivial to combine. Implicit parameters. I don't really get that. Like, do they return an error, or do they, like, I don't really understand that. Flexible compilation compared to similar compilers. Ante's compiler is both incremental and doesn't require monomorphization. I don't know what that means. High level and low level language. Try to bridge the gap between high and low level languages. It has high level abstractions implemented in userland by low level core. I wonder what that means. I do wonder what that means. That sounds interesting, but I don't know if it is what I think it is. Easy lifetime variables. Instead of abstract or numbered names, Ante's lifetime variables are named after the variables they borrow, making error messages more clear. Okay. Like, easier than Rust, I guess. The compiler is on GitHub, so it is. Have a look. Well, a quick glance at it. 2.3 stars, so it's fairly popular. Programmed in Rust with some Scala for some reason. Scala, however you want to say it. Maybe I should actually have a look at this as well for how I should do my language. Granted, this one is functional, but like I was looking at the Rust compiler, but this also exists, so maybe this is also worth looking at. I mean, it is worth looking at because it would give me some more ideas. And it might be a bit simpler. Ante, okay, and there's some posts here. Anyway, so let's have a look into, get into the language tour. I'm just getting some water first. I'm quite thirsty. Ante is low level. Can I zoom in? I can, but it doesn't go to the contents. It's kind of annoying. Let me just move myself this way. Yep. So Ante is a low-level, impure functional programming language. It is a low-level in a sense that types are not boxed by default, and programmers can still delve down to optimize allocation, representation, and memory if desired. What does box even mean? Like on the heap? Yeah, I think heap allocated. Why is it called boxed? Dear Claude, why is it called? Why is heap allocation called boxing in Rust and similar? Assuming it is. So the pointer is a box. You open the box and you unbox it. Interesting. Okay, sure. I mean, I'm all for, like, you know, terms to make things simpler. Not simpler, but like just less verbose. Like if I had a type called heap allocated T, that'd be kind of annoying as opposed to just having box T, right? So like if boxes becomes a standard term, use it. Also, this is 2021. I assume this has been updated since, but like. Okay, so yeah, so that means it began development like 5 years ago, I assume, unless this is not the start date. It is low level in the sense, yeah, it's read that. A central goal of Ante, however, is not to force this upon users and provide sane defaults where possible. Okay, this can be seen in the ability to opt out of move semantics and even temporary references much of the time by using shared types which resemble programming in a garbage collected language with boxed values. Interesting. Compared to other level languages, Ante is memory safe like Rust, but tries to be easier in general. For example, by allowing shared mutability by default. Right, so I wonder how you opt out of that. Generally, application level Ante code. Sorry, so that should be capitalized, right? Yeah, this should be capitalized, the A. I was wondering if that was a thing, but then here it's not. Okay, that's weirdly inconsistent. Generally, application level Ante code is meant to be written with shared types to enable high level code. Application level, while libraries are meant to use ownership and borrowing internally to improve performance. I don't understand that. Why would to enable high level code? Because I guess like they believe that to have high level code you must impede performance. I don't really understand that. Yeah, I don't get that. Literals, integers. Literals can be of any size integer type or any unsized, but by default integer literals are polymorphic. Well, I'm going to go down now. Int type. Where's that? Down here, okay. Integers come in different sizes given by the number in their type, but specifies how many bits they take up. I size and U size are the assigned and unsigned integer types, respectively, pointer size. Yep. So because they're polymorphic, if we don't specify their type, then we can use them with any other integer type. Oh, I see what you mean. Yeah. When no integer type is specified, they default to I32. I've always wondered why they default to I32. Like why not just default to the lowest possible one? Why do many languages have integer literals default to I32? Why not I8? Why not just use the smallest necessary size and expand later if needed via type inference? Yeah, but like you shouldn't just not type your code with the assumption that literals are I32. I feel like that's not a good reason. Overflow becomes a moving target. Arithmetic on small necessary types would need constant promotion rules, and behavior would depend on literal magnitude rather than declared intent. That's a foot gun. I mean, I suppose you could also just require that integers are given a explicit type. But otherwise, like, if you don't use it, you probably just want the smallest one anyway, no? I32 is a sweet spot for the target ISA. Most modern CPUs, 32-bit ops, or native register with operations. Often is fast or faster than 8 or 16. Okay, so actually improves performance, not 2. Type inference direction matters. Inference in Hindley-Milner's-ish systems generally is a concrete default to fall back on when no other constraint pins the type down. And then expansion on demand isn't actually simpler. It pushes complexity into unification. Interesting. So let me create a note from this, by the way, for this post. Go. So this is Ante Lang. Just the Ante language tour. I don't know who the authors are. It says published in 2021, but I don't know if that's true. Probably just created then. So I'll put the access date instead. What's today? Today's the 6th of July. I'm gonna be 20 soon. Tags, online article, link. Okay. So literals. Literals, integers. Oh, okay. No syntax highlighting, but probably use Haskell's one to be fair. It's probably fine. Ooh, no, they use different comments. That's actually quite annoying. I'll do Rust then for now. Yep, quote that. Apparently, well, yeah, apparently, using, it's actually more efficient for computers to perform operations on an i32, well, on 32-bit width integers than 16 or 8-bit. And so i32 is quite a sane default, as opposed to trying to select the narrowest possible width by default. However, I would personally not personally enforce literals to be explicitly typed if type cannot be inferred. Okay, read on. Ante does not implicitly cast integer types. The following is a type error. Interesting. So not even up. So like this doesn't implicitly cast to a U16. It gives you a type error. So so that means you would have to cast up, which is interesting. Because obviously you don't want to have a narrowing error, so you wouldn't choose U8. But I wonder why not choose the bigger type. Holy lag, man. Do I have like processes open that I'm not aware of? Because my thing's like not. I feel like it shouldn't be this slow. Also, why do string literals use lowercase? I mean, I guess I can. Yeah, fair enough. Because the types are uppercase. Plus, probably helps with parsing, to be fair, to not have it be uppercase. So, I wonder why not just have an implicit cast to the largest, the largest width type. In this case, U16. I feel like that's fairly predictable. I feel like that's fairly predictable and saves the annoyance of having to upcast. Algebra can use it. Okay, so floats in Ante conform to this standard as everything else does. I have two varieties. Floats have a similar syntax to integers with a dot. So by default, they are F64, which is also interesting. 32-bit floats can be created with the F32 suffix, of course. Like integers, floating-point literals are also polymorphic. Oh, I didn't say that. If no type is specified, they will default to F64. Okay, I don't know why you have the comments there then, but then it repeats it there. Booleans, bool type are the true or false are lowercase. Characters are in Ante are a single 32-bit Unicode scalar value. Note that since string are UTF-8, multiple characters are packed into strings, and if the string contains only Ante characters, its size in memory is 1 byte per character in the string, as you would expect. Character escapes can also be used to represent characters not on a traditional keyboard. Yep. Strings, Ante supports several different string types for different use cases, but the most common string type, which English is given by default, is represented as a reference counted pointer to a global UTF-8 string with copy on write semantics. Copy on write, so it creates a copy if you want to change it. Or if its size is changed. Not automated. String literals are stored as we know in memory, and therefore do not require heap allocation, but therefore are also immutable. Attempting to mutate these values, however, will be treated as if they are always aliased and will invoke copy on write semantics, and not copy to the heap before mutation. Makes sense. Same as, again, really any language. This is meant to be relatively efficient for the general case, although users with more specific optimization whatever requirements may wish to use alternative string types. Examples of alternative types include not terminated, c.string. Interesting is c.string, and the OS dependent OS string. Yeah, I've always wondered, you have C string, OS string, why not have like C++ string and like Rust string? I mean, I guess those could come in their own libraries, but I feel like that would make interop easier, no? Like, why not have that? This is meant to, like... Yeah, anyway. var my string equals hello. Actually, I will say the Rust ABI isn't concrete yet, but, like, the C++ one is. Like, interop with C++ shouldn't really necessarily require you to use the C API or ABI. I mean, you may want to use C ABI anyway just because it's convenient, but, like, if you only want to interop with C++ specifically, you could have a C++ library that like has those types, right? Or even convert the C++ to the other libraries way of doing things if that is better, right? But like again, I don't know, like how much do Rust strings and C++ strings differ? I would assume they're fairly similar, like standard string, I mean, but maybe I'm completely wrong. I don't know. My string equals hello. My string. String increments copy with a relatively cheap RC increment. Implements copy by default. Modifying my stir will not modify hello. Yeah, so here it implicitly copies. I'm honestly not a fan of that. Like, you don't really have a choice. Well, I mean, you do have a choice, but like, you don't really. I've never liked it because like it's just like here this is the exception. I don't like it when things are exceptions. I like it when things follow, pretty like rules consistently. Having strings be an exception where those just happen to be implicitly copied, I'm not a fan of that. String interpolation, Ante supports string interpolation via $sign or this within a string. Within the brackets, arbitrary expressions will be converted to strings and spliced at that position in the string as a whole. Yep, I also like this. Even like without the $sign, you could argue, but I suppose it just makes it a bit easier, doesn't it? Variables. Also, you can $sign name. Yeah, sure. Variables are immutable by default and can be created via $sign. Also notes. Sorry, they're immutable by default. Well, they're not really variables, are they? Also note that Ante is strongly statically typed, yet we do not need to specify the types of variables. This is because Ante has global type inference. Yeah, not a fan of that. We can optionally specify a variable type with this. Yep. So these ones start with var. So they're called variables, but they're not variables. Mutability. A variable can be made. So a variable can be turned into a variable by using the var keyword when defining the variable. Yeah, we need to have better names for these, like storage classes, like something. Objects. Mutable variables can be created with var and mutated with : equals. Okay, that is fucked. Why would you use : equals for mutability? Like the whole point of, or mutation, the whole point of : equals is that like it's similar to this syntax, just with an implicit type. So like surely you would use this for declarations. That I do not understand. Here's another example showing a function that can mutate the passing parameter using a temporary mutable reference. So interestingly, you have var and mute as two different keywords in this language. I wonder why not just have mutable counter and then mutable counter here as well. I guess because it would just make things more ambiguous, but that's kind of like a syntax issue as well. Are we still under? No, we're in a different section. So mutability, variables. There has to be a better term for storage. I don't know, for like storage identifiers than variables, because it's silly when variables are not variable. Even sillier, yeah. These docs really highlight that by having a var keyword to make variables mutable. Yeah. But then still calling them variables even when they aren't prefixed with var. Always strange. Mutability. Not my best spelling performance. Let's copy this. What the fuck? Just realized : / is return type. I wish this was an actual arrow. I wonder why it's not. Huh. Double slash equals is actually pretty cool. Anyway. Maybe Go would be better syntax highlighting. Yeah, Go works pretty well there. So let me use Go instead of Rust. Just for these. I don't understand why you would use boom boom to signify mutation when like the whole point of that syntax is that it is similar to declaration syntax of let x colon t equal foo. Yeah, I don't. Yeah. I also wonder why you would have mutes and var as like separate keywords. Like one creates a temporary. Mute creates a temporary reference, whereas var declares a mutable variable, like mutable storage identifier or storage object. Just object even, mutable object. But why a temporary mutable reference? But I feel like these can be unified anyway, like how Rust does. I don't know though. Mute expression lets you. Actually, let me read this. So var counter equals 0, mutable counter. I mean, it's essentially equivalent to Rust's mute and then the ampersand, right? That's literally what it is. We can do this with mutable state. Right, so you have a mutable i32. Like here as well, like mutable i32, not var i32. That was sort of kind of weird to me. Like why, like that's different than var. Like why are we using mutes in the type? Even weirder, considering mute is also used in type parameters instead of var. Like that was just seems backwards to me. Or just not backwards, just a bit inconsistent. I don't know, like unintuitive. Iter array function element if oh holy moly. Iter, no recursion. If even elem, then counter plus equals 1. Although in practice it is good to prefer immutability. Array.filter even count. Array filter evens and then feed that into count. Yeah. What does filter even do though? Doesn't filter literally just do, like, just also use mutability but just like recursively instead? Yeah, that also doesn't really agree with me. Because then, like, if filter happens to not be implemented recursively and instead be implemented as a loop, you know, with like a mutable thing, then also this is a return type. Counter is a return type. The bigger issue here is that you're using this as a return type. That's the weird thing. So this is just a weird example altogether. Mute expression lets you take a temporary mutable reference to the given expression on the right hand side. In the case of variables and struct fields, this reference will refer to the existing value and will require the original variable to be mutable. In the case of other values, such as blah, 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 a temporary mutable reference is still obtained. So you have implicit copies unless you use mute. So do you have immutable references? Or only mutable ones? Because like, what if I don't want to copy it, but I don't want it to be... What? Are there immutable references? Because it seems like the only way to avoid implicit copies is via mute. Which again is why Rust has mute, but also has the ampersand to get references. Or even like a ref keyword would work. We'll see, it'll probably come up later. The function line is given an error because we never declared bad to be mutable. Yeah, makes sense. Functions in Ante are also defined via equals and are just syntactic sugar for assigning a lambda for a variable. Hey, that's my idea. This is foo1 and foo2 below are exactly equivalent except for the name. So it is syntactic sugar. Really? I wonder why you'd even bother. Like, why even bother having this syntactic sugar, honestly? Like, if functions are just variables, just have it like that, honestly. Functions can have their parameter types, because then you have two ways to do the same thing, which I don't like. Functions. I don't understand why you would treat functions syntax as syntactic sugar for assigning a lambda. Instead, I would push to just have to just assign lambdas, as they aren't even more that much more to type anyway. Like, looking at my thing, my I've listened to the last project ideas. Like here I have, not here. Is it here? Yeah, no, it is here. Like here I have the same thing, where you declare a variable and assign it, and likewise you can declare a function and assign it. So if I have a function, let's just, I mean, ignore the mutable here because it's not really relevant, but like declare f at equals, it's just colon equals, like it's for type inference, because it infers a type from this, because you're passing lambda. So A is U32, B is U32, return U32, equals B, right? And like if I didn't have that, so like let's say that I have like a function for lambdas. Because I wanted to think of some kind of prefix, but I couldn't think of one. But now I'm realizing that function probably makes sense. But like if you were to do this, normally, right? Like you would like declare I mean, one thing is like you can't make it mutable, but let's assume that it wasn't mutable then. You declare a function with your arguments, right? So probably like this, a at where's my at sign? U32, B at U32, which is U32, equals A plus B. Like, is the difference that big? I don't know. And like, again, like, now you have two ways to do things, whereas if I just support this, it doesn't matter. I wonder if there should be a space there or not. I wonder if there should be a space for many of these things, to be fair, but... yeah, anyway. I don't... yeah. Where was I? I saw so many tabs open. So laggy. I need a way to just like close all these tabs at once. Yeah, otherwise you end up with two ways to do the exact same thing. Where one is an intuitive, yeah. Functions can have their parameter types and return. Yeah, I would reserve syntactic sugar for more cumbersome things, or even just design the language differently at that point. So the sugary way is the only way. And for lambdas, like, would you get rid of lambdas or like make them different? Probably not. So functions can have the parameter types and return types specified via colon. Yep. Module namespacing. By default, functions are placed in the current module. Optionally, functions may also be placed in a child module by prefixing the function's name with the module's name. So foo.bar. Okay, so you don't actually like have like a scope. You just prefix it, and that automatically puts it in a namespace. Sure, I guess. Although I prefer if it's like file bound. I feel like that'd make a lot more sense. Yeah, I'm gonna also mention that, of course. Module namespacing. Why not make them file bound? Sure, it allows for you. Yeah, I don't know. I feel like it just adds redundancy for no real benefit, and also promotes worse code since people may then be enticed to mix modules in one file. But existing is also how methods are defined. Yeah, I feared this. In Ante, the dot operator can be used for method calls as well as field accesses. When using method calls, a function name will be searched for in the module with the same full path as the type of the first argument. Methods may only be added to types defined in the current project. If the type is defined in a dependency, it may not have new methods added to it. Oh, so if a type is defined in a dependency, you can't add new methods to it. So like, then the orphan rule is in effect, first of all. And second of all, then you lose like any benefit of being able to do this in the first place. Like I assume the reason that you would allow this would be so that you could extend it from an external file, but if you can't do that anyway, because it's a dependency, then like, what's the point then? The self variable can be used as an argument which is implicitly of the same type as the module name. Also, I'm to impl. Impls for effects, right? Or for structs, I guess, or types. And it's implicit, so not explicit, which I probably agree with. Like other parameters, self on its own will you use move semantics. You can append a reference type such as ref self. I mean, that's like another reason why it's good to not have an implicit self. Because like with C++, the way you do make like an immutable self or immutable this is by adding const to the function signature, but like it's just like const just like thrown in after the argument list, which is a bit like goofy. I feel like just having the self there actually helps things just be a bit more clear. Type vec a equals vec.new equals vec.push equals call the method. This can be done without explicitly importing vec.new or vec.push. Okay. Whatever. This is actually a sub thing, I didn't realize. Methods, I've come to appreciate the explicit self / this like in Rust. For struct methods like in Rust. Since in Rust, less because they like expose the otherwise implicit parameter, and more so because it allows you to directly modify or like directly modify the type parameter. For example, to get a mutable self in Rust, you would have the first parameter be just like self, not even mutable self, right? Mutable self. You aren't even required to add the type annotation of self, which is quite convenient. Unless I'm tripping and it's like this. Let me just double check that actually. Rust, mutable self. Oh, it's before that, okay. It's mutable reference. Whereas in C++, making this constant, right? Making a const this requires you to add const after, after the function parameter list, which can appear kind of random, which isn't necessarily intuitive. Likewise, omitting self in Rust in a Rust struct method makes that function static, or implicitly static, whereas C++ requires the static keyword. Which, to be fair, I'm less of a fan of Rust in this scenario, as I feel the static keyword helps with skimming for static functions, for static methods, as well, that being said, I should say. From Whitespace. Ante uses from Whitespace up to color code and prevents debugs, such as Apple's infamous go-to fail bug. What? I guess a bug got deleted. In general, Ante tries to be simple with his backslash semantics. If the next line is indented 2 plus or more spaces, then an indent token is used. If the line differ by only 1 space, it is considered to be a mistake and an error is used. Dude, just use tabs at that point. Oh my god. If the lines differ, yeah. There's no notion of indenting to a pass an exact column like in Haskell's offside rule. It's called offside. Okay. Secondly, anytime an indent to a previous column occurs, an unindent token is issued. Okay. Indents and unindents follow a stack discipline. Each unindent is a return to a previous indentation level rather than to a new one. So the following program is invalid since the else was not unindented to the previous indent level. Yeah, that makes sense. Thirdly, when a new line between 2 lines of code at the same indent level occurs, a new line token is issued to separate the 2 expressions. Only at the same indent level. Which makes sense. I don't know why I talk about tokens. Like, the spec really shouldn't talk about tokens to that extent. I feel like from these 3 rules we get indent, unindent, and new line tokens, which the parser can parse just as if they were this and tokens in the source program. I mean, like, it's cool for implementation details, but the programmer probably there probably is a better way to communicate that in terms of like semantic meaning as opposed to the tokens. Like what does a new line token actually represent? Like, now we're comparing to this, but that assumes I even know what these are in the first place, right? Which I may not necessarily. Line continuations. With the above 3 rules, the syntax is transformed into one with the equivalent of an explicit. Boom, boom, boom. 95% of programs just work now, and Ante would stop there if I wanted to. And for a long time it did. A problem arises with the 3rd rule of using new lines as these tokens. Sometimes users may wish to continue an expression on multiple lines. Why is it explaining it like it's like a revolutionary thing? This is a problem with parallels of automatic semicolon insertion in other languages. It is. The main difference between Ante also has simple whitespace to help it clue into this problem. Sorry, Python exists though? Yeah, no, that's Java. I'm not talking about Java. I'm talking about significant whitespace languages. Okay, no, there's Python here. And this solution was more of a band-aid. It followed, so it doesn't do this anymore. That's good. There's also a similar rule for aligning new lines while we were inside these. This solution was quite annoying in practice. It's much more expression-oriented than Python, especially with pipelines. I mean, pipelines should just be indented. Like, as you would end up with a long chain of lines ending with slash. Like, that's more of a pipeline issue, or like at least make pipelines like the exception or like something, but just indented. So what to do instead? Holy moly! In practice, this ugly bit of syntax tended to discourage the otherwise good practice of splitting long lines onto multiple lines, and it needed a better solution. The goals of the new solution were to be unambiguous, ergonomic, match developers, mental models. Sorry, doesn't Haskell have significant white space too? I don't think Haskell uses backslashes, does it? And to issue error messages if needed instead of suddenly inferring the wrong thing. Okay, so the solution was based on the observation or observance that when programmers want to continue lines, they almost always use indentation to do so. Shocking. Thus, to continue an expression ante, the continuation must just be indented, and you can continue to use that same indentation of multiple lines. Yeah. I mean, again, I'm not really surprised. Why? Sorry, why is there so much yap in this section? The spec, I feel like, should be... Ooh. Like, we're talking about Ante's history here. I mean, fair enough. I'm not saying it's not interesting. I'm just saying, like, from a docs design perspective, I feel like you wouldn't include such detail. But whatever. The goals of the new language should to be unambiguous, ergonomic, match developing a multi-program, and blah blah blah. Okay, this is done by tracking when this is done by tracking when an indent is expected in the lexer, and only issue the indent if so. Ante's grammar is designed in such a way that the lexer only needs to look at the previous token to find out if it expects an indent after it or not. These tokens that may have indentation after them are if, then, else, while, for, do, match with, along with equals, and this, the arrow sign. And the assignment operators semantically, these are the tokens needed for if expressions, loops, blah 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 blah. This is a list of tokens that a programmer would normally need an indent for a block of code after. Again, this is very obvious. An important part of this being implemented entirely in the lexer is that operator precedence after continued lines just works. It's harder than it may seem if continuation is a parser rule. Again, what's about the lexer? Why are we mentioning the lexer in the docs for like the language spec of like how it reads as opposed to how it is implemented? When the lexer sees an indent without one of these tokens preceding it, it does not issue an indent token and also does not issue new line tokens. Again, like, what does that even mean? Like, what is an indent token like mean in the grand scheme of things? Like, say what you mean, not what you do. Know that this is tracked on a per block basis, so if we wanted to, we could also still use constructs like if inside these blocks with ignored indentation, since it would be indenting to a new level, and that new level would have the indent tokens issued as normal. With this rule, we can continue any line just by indenting it. Here's a previous example, again with a new rule. And then it sneakily has the pipe as an exception, but doesn't mention it here for some reason. Like, I don't know why you'd say all this, which is completely unnecessary, but then not like mention the fact that this isn't indented. Like, I mean, I'm aware it says it here, but like, why isn't this just, like, this is a paragraph, just have that here. Similar to how, like, in the previous section I commented on how there was redundancy with the comments and the... Anyway, I mean, yeah. So piping is the exception to the programmer's typically things. Natively trying to follow the lines, however, shows us another nice property of the rules above. We get an error if you mess up. Wait, so this is an error. Okay, wait, so it is an exception. But then why not make it an exception? Like, this is, like, if you're going to be verbose in your documentation, talking about, like, details, the details I would include, that, like, I would say, you know what, yeah, include that. It's not the implementation details, not the history. What I would explain is the rationale, right? So, like, why are we acknowledging that this is an exception to how programmers work, but we're not going to explain, therefore, why we didn't accommodate it. Now, personally, I wouldn't accommodate it. I would not have this, but that's because the rationale is having consistency. Like, you get what you expect, right? I mean, not even what you expect, but like what you can infer is what you get, right? Holy cop chase. Here's a fixed indented version. Is this a... This must be an anonymous function? Yeah, this must be shorthand for like x and then x plus 2. I don't know why you would use that example without explaining it first. That's another issue I find with documentation sometimes, is that they just like throw in examples of things that haven't been explained, which means it's kind of hard to understand what's going on, just ask more questions, and we don't even get to it until quite a bit later, it seems. Here's a fixed edited version, yeah. The other examples were as expected. By the way, I actually don't want this in my language. For my language, I want to reserve the underscore to have piping targets. So like the result of this would go into the pipe. I feel like that's better than having just this be some funky lambda syntax. You could do like a $sign instead, like $sign plus 2, but even then it's like, ooh, that being said, okay, that being said, if you, if you had, oh, for fuck's sake. See this? Nope. That's something else. Why is it all the way up here? Okay, right. Suppose that lambdas, so let me just do lambdas. Suppose that lambdas, with Python syntax, suppose that you had declare, okay, not even, so suppose you had, one idea to do lambdas is have an fn keyword, right? So fn and then like a of type u32. I use at for type. This is something that might change, so just go along with it for now. And then you have the return. I use an arrow just because this would look too goofy to me. I prefer if the return type was like specific, like a function, like the type of the function is this, and the parameters types are these. The return type isn't the type of the function, which is why I don't feel comfortable giving it like the same symbol. It just does, it's just never really read right to me. The return type should be the return type, right? And then you have whatever. Like in this case, you'd use the colon a plus b, and then if you want to, you can extend that to a different line. But yeah, I'll put it here, right? So if you had this syntax, then it would be kind of difficult to simplify it. Also, like, this only works for single arguments too, right? Or you could infer the type as well. So like a simple one would just be a, b, and then a plus b, right? Like, let's just look at this first, because this is the simplest example, right? And let me remove a, or b rather, so it's just a plus 3, because that's what we're actually comparing here. So we have a function a, and it's just a plus 3, right? Now they have this, so this is a shorthand for this basically, right? Now I'm thinking, first of all, you could remove this, so this is together. That just helps make things a bit less verbose. I mean, it's one space, but like, first of all you have that. But then I'm thinking, if you instead had a $sign, so a $sign a is a lambda, and then a plus 3, then the shorthand could then be $sign plus 3. So $sign plus 3 is shorthand for this. Now, yes, it's kind of goofy having a $sign for a lambda. That might seem a bit strange to people, but like, first of all, who cares? You get used to it. And like what else you do? Like an L for lambda. Like, if you had more symbols, it'd be nice. But like $sign is unused, so might as well use it for that, right? So $sign a, and like this I can get behind. So then I have like a map passing this lambda, right? So like, let's say I have a list, or here map lists this. Otherwise, we're looking at like a fn this, which just seems a bit disconnected. Or like having, I mean, I wouldn't have this. I'd have a $sign here, which also gets kind of disconnected. So if you had this, it feels like like, although like you wouldn't like intuitively think, oh yeah, obviously because you can do this, this is possible. Like you wouldn't think that, but you'd see this and say like, okay, well I can at least tell that because they have a dollar sign, it means lambda. So if I see a dollar sign, it means lambda. So now whenever I see a dollar sign, if it's followed by a function argument thing, then I know it's a lambda argument list, whatever, like a full one. And then if it's not, then it's just like that, right? Insertion. Now the issue here is, what if the argument is a function call? So then I'm calling like a function with like a variable a. That can very much be an issue, right? So that's not ideal. I mean, one idea is to separate parameter lists and function calls. So parameter lists use curly braces instead, such that function calls are explicitly different from definitions. But that feels like, like not really necessary. So I don't know. But that's right. Just a thought. For the time being, if I think of a better solution, I will of course do that. So this works as expected. Operators in Ante are normal names like foo or bar, just with special parser support, so we can call them infix foo plus bar instead of prefix plus foo bar. Okay, most operators are defined in abilities in the prelude. Here's some common operators. So add, sub, multiply, divide. And there is precedence. Modulus rather than remainder. Yep. Honestly, I don't even get like having this operator, like for how infrequently you use it. Unless you like you have percent sign for. Well, I guess a good thing is that you can then also reuse it for like percent plus, percent minus, and stuff like that, like as Zig does. I think that's pretty intuitive. Equality, EQ, ability, EQ. And these abbreviations are killing me, but and then not equals is just defined as that. Comparison operators are implemented in terms of the CMP ability. Please just call it compare, bro. Type ordering equals lesser equal greater. There are also various compound assignment operators. Yep. Logical operators have their names spelled out fully and with short circuit. If true and false, then print foo. If false or true, then print bar. If not false, then blah blah blah. And there's short circuit. And binds higher than or, so the following parts print. Yeah, just. I would rather you just use the brackets. Since filling with individual bits is not a common operation, and precedence of these operators in other languages is often confused, there are no bitwise operators. Cool. Subscript operator. Dot this. Yeah, it makes sense. Although at this point just do dot at. But like, yeah, fair enough. Note that dot this has a high enough precedence to be used in function calls. Why wouldn't it? Additionally, references to elements can be retrieved using the subject operator with a reference kind. So there is a ref keyword. Okay. God damn it. So there is a ref keyword. Yeah. So that answers my question. There is also a ref keyword, but it isn't. So why isn't it mute ref instead of just mute? Dereference operator, copy and clone. Also, for stuff like this, I think it is understandable to have an operator, or to have a special operator like ampersand, since it's probably such a common thing. I mean, something like copying, you could say as well, but reference operator, copy and clone, or cloning rather. Dereferencing reference in Ante requires the element type of the reference to implicit either copy or clone. Both abilities have the same semantics in that they both perform copies, but types implementing copy are generally expected to be cheaper to copy. Okay, expected to be, but not enforced. These abilities can be called via the copy or clone functions, but there's also the postfix star operator available as an alias to copy. Interesting. So why is it not like a dot? Why isn't it like a dot ampersand or something? Oh, okay. Dot boom as a postfix operator, as an alias for dot copy. Is rather strange. Doesn't help that there's no like dot ampersand for references either. If you need to access, if you need to access a struct field, this will retrieve a reference to the given field if struct is a reference. Otherwise, it will attempt to copy or move the field out of the struct. What if I don't want struct to be a reference, but I want to get a reference to it anyway? Also note that if I guess I can add ref, but then like it's implicit. What? Also note that if a value was expected but a reference was provided, there's a coercion such that the reference will be automatically copied. Providing its elements type implements copy. This means foo above. So like really copy means trivially copyable, right? Like that should be what the tree is called. Trivially copyable, such that if I need a reference, I will happily take a copy, right? Really, the copy trait / ability should be called something like trivially copyable, or like inexpensive copy, or like cheap copy, really cheap copy. Since they are supposed to be, it makes it, and not having a clearer name makes it easier to confuse with clone. And personally, like clone sounds cheap to me, because I mean I play Clash Royale, so like clone just sounds like a like a cheap copy. If anything, clone to me sounds like the cheap copy, just because of how clones are typically weaker than the original in pop fiction, I guess. Yeah. It does make sense though that that trivially copyable types can be passed to parameters requiring ref. Although I do wonder if there's like a way to enforce that it must be cheap copy. No. Pipeline operators. Actually, let me just add this question. Or I wonder, is it possible to... How could one go about enforcing... Okay, how could a compiler enforce that a cheap copy is in fact a cheap copy? That is right? Yeah. Pipeline or sugar, it can go backwards too, for a function application and serve to pipe the results from one function of to the input of another. Yeah, xfy is equivalent to fxy, and functions similar to the method syntax in object-oriented languages. Yeah, I mean, I don't like how we have this, like the first argument just disappears. I'm not a fan of that. It is left associative, so this. Alright, let me guess. So x becomes fxy, and that's fed into g, so it becomes g of fxy and z. Yeah, this operator is particularly useful for training iterative functions. Parses CSV's data into a matrix of integers. Yeah, I mean, it's awesome. Like piping is by far just the coolest thing, and I really wish other languages had it. Like more like imperative languages, like Rust, man. Like of all the features Rust could have ported, it didn't think to port piping. Instead, it went for like the monad dot thing, but I don't like that. Lines text, skip one, split, map parse, collect. And what does collect do? Into a vector, I guess. In must do. In contrast to this, the left one is right associative and applies a function on its left to an argument on its right. Where blah 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 is used mostly to spread operations across multiple lines. This is often used for getting rid of parentheses on one line. Yeah, I guess not Rust. Fucking Haskell has this via the $sign operator. Yeah, literally the $sign operator does that. And then for function application, you use the dot. Now that I think about it, yeah, the dot for function application does make sense. I mean, like it's mathematical, so like it makes sense in that sense. It makes sense in that sense. But also not really. Nah, piping's different. Anyway, left pipe. Print square root of 3 plus 1. What I don't get here is that you can also just write this the other way around as 3 plus 1 to square it to print. Like print square root of 3 plus 1. Like, is that cool? Is that useful? Is that more readable? Print the square root of 3 plus 1. Print the square root of 3 plus 1. Like, I'm gonna say no. I'm gonna say just do 3 plus 1 square root print if you really want to. Like, imagine if this was collect, map parse, split thing, skip one, lines text instead. Like here, no, like we're saying no, we want to take lines of text, we want to skip one, we want to split this, we want to map the parse and collect. So like, but that logic, why we want to say, okay, I want to get 3 plus 1, I will take the square root of it, and then I want to print it. Right? Like this would only be useful for like very short statements. At which point the nested brackets don't really matter anyway. That's my take on that. Pipelines and methods. Note that method calls. I should rewrite this actually. What section is this? Pipeline. Yeah. I don't really see the need for a left pipe. For a left pipe, since all left pipes can be written as right pipes, and right pipes, so it's better to just have one or the other for the sake of not having arbitrary ways to do, sake of not having multiple mostly indifferent ways to do the same thing. Like, you could argue then, like, oh, then don't have actually no, just no. Right. Note that method calls can still be used with pipeline operators. Method calls can also work standalone, e.g. push 3 is short for that, as long as the expected object type can be figured out by the environment. So modify code such as vec of and then split first. Question is, why the fuck would you do this? Am I tripping? Why? Literally, why would you do this? This might just be the most useless thing. Like, why would you support this, first of all? And then why would you have, like, you can just dot. Like, that's kind of the whole point of dot. The whole point of dot is that you can just dot. I don't understand why you need to do this. I don't understand. This literally makes no sense to me. Someone please explain. God damn, so it is markdown. It is cool that if I copy paste it, it copies and pastes as a markdown. That's quite good for my particular use case, which is taking notes with markdown. Is Ghost and syntax even cutting it? Yeah, it's fine. Why? You can just vec dot of one. I guess this is like a functional programming thing. Okay, this very much seems like a self-inflicted issue, or like a solution to a self-inflicted problem, that is using functional like FP style function calls. If you just used parentheses like other languages and maths, may I add, you would be able to just vec dot of 1 2 3, right, and then dot split first. And like, what? Equivalently, let's use like Go, I guess, for this as well. Like 1 2 3, pipe that into vec of, then pipe that into vec split first. And if you really wanted to use piping, Yeah, okay. Quick intermission while I just check what the timings are here. Portugal versus Spain. 8 p.m. Okay, we're chilling. We are chilling. What is today? I don't even know. I also don't have like a date on my computer. I mean I do, but I don't know. I don't have the day. What day is it? You've probably never said that before. Monday. Okay. Right, pair operator. Ante does not have tuples. Instead, it provides a right associative pair operator to construct a value of the pair type. We can use it like 1, 2, 3 to construct a value of type I32, I32, I32. Which in turn is just sugar for pair I32 of pair 32, I32. Let's keep reading. Compared to tuples, pairs are simpler. They do not need to be built into the compiler or its type system. Instead, they can be defined as a normal struct type in the standard library. But the syntactic sugar is built into the compiler anyway. Also, what do you mean the type system? Like a tuple is just... Let's keep reading. Easy to work with. Because pairs are just normal data types, we can get all the capabilities of normal types for free. Yeah. Okay. My question is, why do they need to be pairs? Why can't it just be a list of things? Like, why specifically nested pairs? For example, we know all pairs will have exactly 2 fields. This makes creating impls for them much easier. Like, this isn't a linked list. They have 2 fields. Cast pair string equals impl cast pair AB string via cast AB. Right, so you can have a tuple to a string where you just iterate over all the tuple things without needing to have variadic template arguments. I mean, this is an interesting alternative to variadic template arguments, but it's also like implicit as hell, so I don't understand why you would not just use a template. Let's complete the task of converting a tuple to a string. Okay, I reduced all this. Just as efficient. They have roughly the same representation in memory. The exact same if you discount alignment differences and Rodinger fields. Sure. Markov composable, having the right associative thing operator means we can easily combine pairs or add an element if needed. For example, if we had a function unzip, we could use unzip even on a list ABC to extract a list A, list BC for us. Sorry, I've got crazy glare on my screen. Unzip fn list of AB to a list of A, list of B. Oh, I didn't see that. We can use unzip on even a list ABC to extract a list A and list BC. This means if we wanted, we may implement unzip 3 using unzip, though this would require 2 traversals instead of 1. Well, is it like an unzip n? Like you can make the return type a pair as well, right? Yeah, why not just make it a pair? Oh, because it is a pair. But then why do you even need to do this? Another place it shows up is when deconstructing pair values. Let's say we wanted to define a function first for getting the first element of any tuple of length more than or greater or equals to 2. So there are no more tuples. There are no one tuples as well. I even like tuples, but anyway. And third, for getting the third element of any tuple of length y equals to 3, we can define the functions. Yeah. So the parser will parse third and the cool as follows. Question: what if I want to only accept two thing tuples? I guess I specify a type, but like, what if I want it to be generic still, but just only 2? Note that to work with nested pairs of any length greater or equal to 3 instead of 4, our implementation of third will really return a nested pair of third rest. One last minor advantage of pairs is that we can use the fact that this is right associative to avoid some extra parentheses compared to if we had tuples. Man, anything to avoid parentheses. A common example is when enumerating a tuple. Most languages would need 2 sets of parentheses, but in Ante, since tuples are under nested pairs, you can just add another comma. So before and after. Kojo would argue that this is better than this because it literally reads like, yeah, I have a tuple 1, 2, and I have I, not I, 1, and 2 in one tuple. So I don't like this. Yeah. Finally, it's necessary to mention that the earlier cast example printed nested pairs is 1, 2, 3, whereas the show instance in Haskell printed tuples are 1, 2, 3. So you have to manually add the things. Again, that's kind of annoying, isn't it? I don't know, man. It's kind of annoying, isn't it? What the fuck is going on? And these two functions will cover all possible lengths of nested pairs. Yeah, I don't agree with this. I would just have variadic syntax with like ... or something, and like use that. But I found that people are weirdly adverse to ... I don't understand why. But yeah, this is a whole lot of weirdness here. So I'm just going to move on. Lambdas in Ante have the following syntax: function arg1, arg2, argn. Like here, there's ... but we're not going to use this in the actual language. All functions in Ante must have at least one parameter. When the first argument is excluded, this is taken as sugar for a function taking a unit parameter. So much sugar in functional programming. Function, I mean, in FP languages, they don't have to have it in this manner. Right, so an MTFN is just an implicit thing. But like again, like why not just include the implicit thing? Like I get it's syntactic sugar, but the difference is literally negligible. Like I don't understand why you wouldn't just include it to make it more clear. At least in a language. Hold on. Taking a unit parameter. I mean, like this is also like really straightforward if you just have an empty brackets. Like if your language always uses this for function call parameters and syntax and stuff like that. What for function calls and parameters? If you wrap them always in parentheses, then this wouldn't even like be weird anyway. So additionally, function definition for ABC equals body is sugar for a variable assigned to lambda. For equals function, yeah, okay, we've gone over that. I'm not a huge fan of it, but it's what I mean. Yeah, it's obviously understandable. I just don't think it's. I think it'd be interesting to not have it. Lambdas can also capture part of the variables in the scope where they are declared. When they do this, they are called closures. How are they capturing? Just implicitly. Yeah, no, that's fair. That's fine. I'm not a fan of how in C++ you have to do it explicitly. Like it's there. Organ equals 2, data equals 1 to 100. Map data function x to x. I can't remember how Rust does it, but oh well. Man, no brackets here. don't like function programming. Like I don't like these bracketless like things either, because well, the function call syntax, because like I also never know when I need parentheses and when I don't. Like you tell me that this doesn't, because this is just treated as one expression, but like it's just so, it feels so messy. I don't know. I do know it feels messy. I don't like it. I don't like it. Like it's not just that I'm not used to it. It's that even if I were used to it, it would still be weird, because like objectively, map is one token or lexeme, data is one lexeme, but like function x to x plus argon is one expression that fits into this like group of lexemes. Like it's like there's no, like it's not super clear. And like I would presume that if I want to have this reversed, that I would need parentheses. Like if I had the function first, I would need parentheses. So it's like sometimes I don't, but if I put it at the end, then I can get away with not having it. Like it's just inconsistent. I don't like it. Let me just think, by the way. Yeah, no. I'm trying to think of like if there's like another way to do lambda syntax such that removing this leaves you with something that's like nicer, but like this is already nice. Like it's a foo, it's a function ABC that returns body. I wouldn't use an arrow here, but anyway, it is occurring while Ante opts out of including if it's occurring in favor of better error messages. Thank God it does include an explicit function version where arguments of a function call can be explicitly curried by placing this where that argument would normally go. Yep, I kind of deduced this, right? Is this currying? Is this currying? I don't know if that's currying. I guess it is, but like, adds ABC, A plus B plus C, add 3. Explicit currying lets us curry function arguments in whatever order we want. Yep, huge. A huge annoyance of Haskell is that you can't do that. I mean, I don't think you can. Maybe they made a new feature, but I don't believe they can. Underscore underscore, so G1 just takes 2 arguments. AC, add 3 AC. Yeah, so G1 is equivalent to G2. You know, thinking about this syntax again, you could allow, like, if you use the $, you could type in force 2. Like, if I wanted to create a lambda that's like x plus 2, I could have like $, u, like I32, right, plus 3. And this desugars to the function a I32 is a plus 3. I mean, don't worry too much about like the other syntax, but like if you had a $ thing, you could do this. And then if you want any type, you could do like $ underscore. Ooh. That works quite well. $ underscore then. I mean, or like maybe not $ underscore, but like $ something. $. Like what says any type? I mean, I guess like any. Or like T. Yeah, like whatever. Like something that says any type. Auto maybe. if this is also auto. I mean, if you want auto, you just not include it, right? So just be A. So the equivalent would be just having nothing. But like I said before, the issue with this is that if I want to do a function call, then it would look like I'm defining a lambda, so that doesn't work. Of course, the alternative is just not use a dollar sign here instead of like $ function, like $, even like there, like $. You could do that instead of underscore. And then if I want to type, I do like I32. I don't know. I mean, I feel like at this point it's getting a bit too overcomplicated, but it is an idea. That being at that point, you don't even really need. I mean, well, the benefit is that it gives you don't have to name your arguments. You can just put them in. It also means you can't reuse arguments. That's another, I guess that's another issue. But yeah, I don't know. Like, is this more verbose? I mean, obviously it is more verbose. But like, is this is this so much of a pain to write? Or let's say like it was FN, I don't know, whatever. That you would want to have this syntax. It is a thought. It is a thought. Yeah. Same with how, like, what am I thinking of here? Just functions. I mean, the other benefit is that I can then define a function, like using my language syntax. Define foo, right, equals, or at equals, because it's type inferenced. I32. It's like, instead of having to do like all this, where it's like a function of a of type I32 that returns I32, well, a plus 3, let's say. I guess with an inferred return type. Although I'm not a huge fan of inferred return types anyway. But like the alternative to that as well would just be declare foo as a function, which is I32 plus 3. So now I don't care what A and B are. And the benefit of this is that I no longer have like the whole A and B conundrum. Like, let's say I have, because like when I call this function, right, I would only be able to just pass in the values, like 4 and 5, right? Whereas, if I have named, because something I'm thinking as well, is having named function arguments, I think is such an important, like, well, such a nifty feature. But the issue is, like, do I force them? Because if I don't force them, then people can still write confusing code. But if I do force them, then they can't write confusing code. Good. But then it means that for cases where I don't actually care what the name is, then people have to do like A equals this and B equals this, for like a simple like add function, right? But like I want to just do add 4 and 5, like in that particular case, right? So instead, if I just had like, okay, declare add is equal to any I32 or any T, any add, I don't know, whatever, addable, plus 3, right? Or even like any T where T is of type addable, like whatever, and sorry, it'd be double, right? Where T is addable, actually. Like, this is not bad. Because how I would define this in a different language would be like a function and taking T, where T is addable, with a T A and a B of type T, right? Return A plus B. Or if you were to do the whole thing, you have to do like addable T, maybe, where T is addable. something like that, right? It just means that you don't have to name A and B, so they're not named. Like it's just it makes sense, right? It makes sense. This is actually, yeah, this is definitely an idea. Let me do more on this. So let me go back to my language. Here it is. Right, so let's have lambdas. Okay, so we're gonna have oh man, I don't know what comments are in my language yet. I'm using dashes. Okay, so I need Lua. I like the dash because it's like an M dash. That's literally my only reason to use it. But also because you pretty much never else otherwise use. Oh, how do you do closed ones though? Dashes for lines and like this for like inline. It ain't a bad idea. It ain't a bad idea. just mixing and matching my favorites. Anyway, so the following are equivalent. So we have a function lambda, right? For the function. Oh, sorry. The following are not equivalent. So let's say I have a function called add. Well, yeah. So yeah, sorry. Let's say I'm declaring a function called add, which is equal to. So well, let me read this properly. I'm declaring an identifier add, which accepts and is type inferred with a function of A of type addable, so T we'll say, and B T should be at. I could do at T like that, but let me just do this for now. B at T, and then returning a type T, the same type. Well, really, it'd be the type of A of right, like of A plus B. How does Rust do that, I wonder? Is at for type inference a good thing? That's interesting, because I'm using at here, I could also just have at be an operator to get the type of something as well. So type of A plus B is just at A plus B, but then if I do it here, it's saying that it's type T. But then it's like if I want to mix it, it's like at like at A plus B. That's goofy. Or just like at A plus B. Like at A plus B. But then it's like at T. Very interesting. Okay, for now, let me just do type of. Type of A plus B. Yeah, is A plus B, right? Versus declare again add. Also, I have T, sorry, where T at addable. Also, sorry, the where wouldn't be the end. Maybe like here, where T is addable. Let me cook, chat. I want to come back to that because that almost just did something, you know. Declare add. So again, same thing here, but then instead of function add, we just do what, $t plus $t, where t addable. The issue with having functions like this, like lambdas like this, just kind of inside, is that you can't. I think I'm gonna veto this. I don't like the syntax. I think it's just too confusing. I think instead have a function like normal, but then have the dollar. Have the dollar sign for unnamed. So $1 at t, right? And $2. Where the fuck's my keys? At t, right? Okay, so now I don't need the comments because that's a bit more obvious. Anyway, so we have call this like add, yeah, 5.3, right? Whatever. Put it there, because put it like here, right? T equals I32. Which would you prefer? This or just putting I32 there? Quite interesting question, actually. Let's just go with this for now, but that is interesting. Because my issue here is that I have the first argument have the type, but the second one doesn't, because it's inferred. But like, that's kind of goofy. And that's just redundant, right? Whereas if you put it here, then it applies to both arguments anyway, and then you don't have to worry about it. So actually I'm inclined to keep this for now. I know people don't like, well, not a lot of people like, I know some people don't like that for things. I'll do this as well. So I use this for the types, because I don't have a use for curly brackets yet, so let me just do that. I'll just go square brackets, but I guess I can reserve those for arrays and stuff like that. Anyway, so declare add, right? Returning, yeah, type of, I mean, same thing really, but it's just $1 plus $2, where t is again addable trait, and then returning $1 plus $2. So these look similar, but this one is called like A equals and B equals, whereas this one is add, same thing, except it's just 5 and 3. But Kojo, wait, $T. My issue with this, honestly, with clear braces, is that like the angular brackets are just a lot more clear to read. it's just a shame it creates like parsing issues. Now there is a fix to this actually, which is require. So I talked about this before maybe, which is having an is keyword. So like 5 is 3 would be equivalent to in other languages 5 equals 3, right? So then if you want to do more than, you do 5 is greater than 3. And then that is equivalent to, again, 5 greater than 3. Now, is it more verbose? Yes. Does it read better? Yes. And it also means that because this must be followed by the is keyword, excuse me, then I can use these angle brackets. So that's a thought. That is a thought. So I'm actually going to keep angle brackets for now, just simply because they're easier to read. Right? Like, it tells you that add is of I32, I53, right? Whereas if I have like this, I just find curly braces harder to distinguish from non-curly braces, such that I feel like it can be more prone to confusion. Now, I could also just use square brackets, right? That is also another option. Which I'm not opposed to, because then you could instead have, well, I mean, like, still have the 5 is greater than 3, but then reserve angular brackets for arrays. So I have like 1, 2, 3. And funny enough, this is actually mathematically correct, because tuples and lists in maths, sequences, sorry, use these brackets, funnily enough. Yeah, so you'd have like, so like A at 3, right, would be A at that position in the sequence. If I want to have a range, I could do like 0, ... 4. Now really, for a good sequence, to be mathematically accurate, you'd use this, right? But the issue there is like parsing hell. And unless you do like range, like R bracket means range, or like just range even, or like range, but that's also like kind of horrific. Mind you, it's not terrible. Like, anyway, like just to throw some ideas. So let's use square brackets, because the template argument list is still a list, such that I would like to keep it like that. Alternatively, there is also the zig option, where you have higher order time. I mean, it's not even true, I don't know, but like you have you just pass it as an argument. So right, so you have like 5, 3, and that's pretty cool. Well, I mean, sorry, it's not pretty cool, because it's like, okay, I'm adding I32 and 5 and 3, like it just doesn't read right. Or if I were to again like keep this at sign for syntax, I could do add at I32, 5 and 3. Right, but then it just gets a bit annoying if I want to have like t equals at some point. Like, that just looks really weird. So let's stick with the square bracket for now. But anyway, so if basically the idea is that if you use a $ operator, you can have implicit naming. So yeah, named arguments, right? So optionally named arguments is the idea here, and I think it's pretty damn simple. Now, $, you could use a different symbol. You could use, well, I don't know. I mean, like, there are only so many symbols on a keyboard, and the symbols that like are really free are like hashtag, at, tilde, I guess. You know, tilde is actually quite interesting, because tilde should be like a maybe type, so I'll use it for that. Or something, I don't know. And like question mark can be used for other things, so I don't know if that's like reserved. But like, anyways, like the ones that are typically free for use are the at, the hashtag, and the $. Yep, because like an ampersand is usually reserved, There's like a caret, but caret. Yeah. Let's add caret to the mix as well, which is like the Angular thing. Like asterisk and ampersand are reserved for pointers usually. I mean, you don't have to, but like I'm just saying. Like generally speaking, these are what the symbols are. Dollar sign I like, but you could do hashtag instead. But I feel like hashtag would make sense. I mean, sorry, I call it hashtag. It's just hash. I feel like hash should be used for something else. Like I just feel like number 1, number 2, hashtag T. Like I feel like these just feel like they would make sense as something else. Whereas dollar sign just feels right. In a way I can't explain. I mean, it's ultimately is arbitrary. So like I'm just saying I'm going to use what just kind of feels right, and maybe get public opinion. Pound sign. Unfortunately, not all keyboards support it natively. Same with the euro sign. I would actually like to use euro sign for something, but alas, man, we like keyboards need more symbols, dude. Like, give us a bone, or just don't use symbols actually. But for programming, some things are common enough where using a symbol is justified. Anyway, or just have like a hidden. But I don't like it because, well, the interesting thing about this, right, is that it's like it's dollar sign 1 versus something like hidden A, right? The question is, do you ever want to have a hidden variable name that is a useful variable name, right? Like, if I have print hello, or like print 5, whatever, like fuck it. This is not how I would do it. Let me. Okay, calm down. Like, let's say it's something a bit more sensical, like an actual reason to use the formatting, like here, right? Like, is this good? Or would you rather have? Cause like then the arguments would be $1, $2, $3, right? Whereas if I have, like if I understandably want to have like format and like 1, 2. That being said, I could also just like $format. I suppose there's like nothing stopping me from doing that either. But it's like, generally speaking, do I want it to be hidden, or do I want it to be format equals? Bro, I'm gonna cry, bro. Format equals, right? I don't know, like I kind of lean towards the format equals in this case, because like it's not just an arbitrary argument, and like then it also means that you can use order. I can have 5, 3. How do I keep doing that? I can have 5, 3, and then format equals this, right? Unless you require that this goes first or this goes last, I probably would do that as well, to be fair. Now, of course, it's kind of a non... that's a bad example, though, because for printing, I would rather just have this. Okay, what the fuck? Like foo plus bar, right? Like, I'd rather just have that. And then, I don't know, like use a $, I guess, to insert it or whatever. Issue there is the $sign now is being reused, so I'm not a fan of that. I think hashtag might be better in this case. Perhaps. Let's just go along with it for now. So yeah, so now that becomes a non-issue, and the first argument can just be a string, so just 1 is fine. It'd be like a printable, right? Printable T. So yeah. So like, what's an example where you actually do mix and match them, like named and unnamed? What's an example of a function that mixes variadic mixes named and unnamed arguments, like print format equals 5 3, right? In Python, named args come afterwards. Okay. I didn't know that was enforced. Man, any examples that aren't interpolated strings? Connect to localhost A080 retries 1 5, right? Okay. So here, I want to have host equals and port equals, so that's fine. Create user, name, age. Create user, Kojo. Again, like name should be Kojo. Like that's just a name. Spawn x and y. Okay, that's fair. Spawn x equals 5, y equals 3. Spawn 5 3. Now that's specifically just because of how we're used to tuples, right? Or like used to coordinates. Spawn. No, I mean, okay, it should be spawn at 5 3. Interesting. I guess as well, it wouldn't like having not allowing you to have like hidden names, like named hidden stuff, would mean that if people do want it, which they probably would, then the workaround would just be to use no names, like just use magic names, which isn't good either. Like you want them to use. Yeah. Okay. In that case, I probably wouldn't enforce it then. I would allow you to have. Like call it whatever you want, like $X, $Y, just so that like for documentation purposes, right? Now for adding it literally doesn't matter, but for other things it might matter. So also would this only apply to function arguments? Also defaults are pretty useful, right? Would you allow defaults for this? Probably. Anyway, that's I'll let you know for now. So anyway, so let's suppose holy glare, man. Let's suppose like logically, can I apply the $sign to any other context? Like if I have $1 declare $1 right equals foo, like whatever, of type whatever, right? So I declare 1 equals foo. Now I can't use this, right? Right? Like, it wouldn't make sense for me to use this. Yeah, like it just like it's just kind of semantically meaningless. Like the only thing here is that I can call my variable one, but like it provides no actual benefit other than calling it one. But like you shouldn't call it one anyway. Yeah, so I'm gonna say it's restricted to this, to functions, and because it's restricted to functions, I'm inclined to have like just call it like hidden A. Hidden A. I don't know hidden A, but like nameless A, or but with a more snappy name, right? Like some keyword instead of the symbol. But like it's just the good thing about the symbol is that I can reuse it here, right? But then the bad thing with the symbol is that I don't need it. Like realistically, I could just do A and B and like T, and that's less hassle too. Yeah, so let's remove the dollar sign. And also function T should be here. I would say T is addable here. Likewise with the other one. And then remove it here. Okay, so to have implicitly named arguments, you could have like impl for implicit, but it's not implicit, it's just implicitly named. Like it's nameless. Like that is the things. Nameless synonyms. Unnamed, obscure, anonymous. So like anon. Let's also assume that keywords are capitalized, by the way. So anonymous, Jesus Christ. Let me ask for some ideas here. What are some keyword name ideas for a function parameter modifier that makes them not need to be named in function call? Like foo format equals boom 553, where 5 and 3 are passed to two anonymous arguments, A and B, that cannot be targeted. It came with a non as well. It's kind of funny. Unnamed, bare, implicit, nokwa. What is no? What? What is no KW? Oh, keyword. What? Okay, I don't know where that came from. Sig. The slash marker. What? How does it look in Python? Can't spell, bro. Is this real? Okay, I'm not even gonna verify that. But what the hell? Yeah, so like an anon, I guess, an anonymous T, an anonymous. It's like hide. Like, it just feels so verbose, man. Actually, it doesn't matter, does it? No, it doesn't matter. But anon. Okay, yeah, let's just stick with that for now. You could use like a symbol, but again, symbols are not my friend for some reason, because there are like barely any of them. A language with like more symbol support would be interesting. In particular, if keyboard just had better support for typing like symbols, it'd be pretty nice, because it makes things more compact and you can associate symbols with meaning anyway. Like I could have like an eye symbol that says like no looking or whatever. That's actually really goofy, but it also makes fonts a bit harder to work, I suppose. But yeah. Anyway, anon makes things anonymous. And if you try to do add I32 with a equals 5, b equals 3, error, cannot name anonymous, error, no known arguments or parameters, A and B, right? And say for T, right? And likewise, if I do this, error, in positional arguments, I guess like calling it pause isn't bad either. But like pause what? Pause what? And like how do you preserve the order? Like, would you like $? Like, I mean, I could use $, or like even hashtag actually, #1 to say like it is the first argument implicitly, and like #1 and 2 for the other ones to say it's also that. But like the order is already implicitly there because you have to use order. Like that's just how programming works. Well, it's how typing works. Like typing is sequential, so there's already a natural sequence, so there's no need to do that. But anyway, so error, no anonymous parameters to bind to. Yeah. Oh, that's been interesting. Back to this. But yeah, so this is something. This is something. Anyway, explicit querying also only carries the innermost function, so using it with nested function calls will yield a type error unless the outermost function is explicit another function. So this is a type error, add 3 explicit integer argument, but a function was given. Like, this just looks like a pain to debug. Nesting... Like, why couldn't I just, like, have X go there, you know? Like, it's kind of... Yeah, it's just really hard to read. Like, I just don't see the point. I mean, in particular, this is to also reduce the arguments you need here. But, like, it doesn't reduce it. It just makes them unnamed and, like, positional. And that's kind of just, like, a pain in the ass. To make a nested function, it needs to be written as a lambda. Like, is this really so bad? In fact, like, it even gets rid of the thing, right? Or just a function definition. But in my case, it would be this, right? So it's like, like, is it really so bad? if I were to give this a name, I can't think of anything. This really shines when using higher ordered functions and iterators. Given a matrix of vec output, sorry, a vector of vectors, output a string format like a CSV file. So joins columns with commas. To be fair, with the piping, which I don't have here, but with the piping, I guess here's an example. This technically desugars into a function x, where x is here, right? So like, if I can do that, is it so bad to just have like a general thing you can do? Like, it's different because like this is specifically for piping, where I read it as like I'm gonna pipe this into here, and I can only use one. I should also point out. Whereas if I just like allow you to just do, like, you know, willy nilly have like this plus 3 just randomly, and it's like, oh no, declare add 3 equals this, right? It's like, what? Like, there's a question of, okay, where is this coming from? So then like I need to like desugar it as this in my head. And really like it'd be like implicitly like T as well, right? Whereas here, like, I don't need to desugar it because I can just think of it as moving this into here. Like, that's the real syntactic sugar. Like I'm not like passing this as an argument to some function. Like, I'm literally just passing this directly here. So like, there's no like desugar. Like, you can think of it like function, but or you can just think of it as what it actually is, which is just placing it there. So I don't know. Plus, then it wouldn't work because like if I had that mean this, then it actually would mean that this goes into the first argument of all functions, and I don't want that. Like, I want it to go where you say it goes, and that's it. Like, no implicit first argument. Like, it only goes where you want it to go. So yeah, I'm gonna veto that. Okay. Okay, control flow. Ante's control flow keyword should be very similar to any programmer used to expression-based languages. I hate English. If expressions expect a Boolean condition, there are no falsy values, and conditionally evaluate and Sorry, if expressions expect a Boolean condition. That's fucked up. There are no falsy values. What? There are no falsy values. What does that mean? And conditionally evaluate and return the then branch if it is true. Should really like put those in like code blocks or something to kind of differentiate those from like normal English. And the else branch otherwise. The else branch may also be omitted. In that case, the whole expression returns the unit value. Ooh. Oh. No. Sorry, I was just thinking of like, for if statements, if you want to have them support pattern matching, the question is how do you make them exhaustive, right? Without having like a separate match keyword. I still don't know. Okay. Loops. Ante includes the traditional for and while loops along with break and continue. For loops must iterate over an increasing range. For anything more complex, streams must be used. Cool. I like loops. What is that? What is that? Is it like an if I is greater than or equal to 3, then wrap it? No, what? What? What does that mean? Did I miss something? I must have. Literally, what is that? Is either a mistake or they just threw this in without explaining what it means, which is kind of annoying. But like it's here twice, so I assume it's not a mistake. For I in 0 to 10, do if I oh, if I is divisible by 3. Right? So it's like if I modulo 3 equals 0, basically, is what this says. That's what I'm guessing that means. It's a pretty cool operator. I'll give it that. It is a pretty cool operator. Yeah, that's pretty cool. I'm gonna take a note of that. Sorry, I'm just really caught up on that. Anti-language tour. Loops. Ante supports or has the operator, which I assume is equivalent to you can do AB, which I assume is equivalent to A B equals 0. Which is pretty neat. I thought like an A is divisible is divisible by B. Also beats A dot is divisible by B. Beat also beats. All my days also beats. Yeah. I was thinking of something else, but it's not really that important or a good thought. For more complex loops, Ante favors recursive functions like map, folds, L, iter, and for underscored, which operates on streams. So iter is equal to 10, print line, print since I inclusive. Iter is pretty good, right? I mean, it's the same shit. It's just that you pass it as a function instead, right? Like you pass what you do each loop as a function, which is pretty cool. Why have I never done that in Haskell before? Like just like make an iterative function. That's actually kind of crazy now that I think about it, because like that's totally a smart thing to do. For allows using continue and break via the loop effect. So looping is an effect. Why the fuck is it an effect? Recursion should be an effect. For enumerate array function. Bro, are these arguments? I don't understand. Index elem. It must be an argument. If no, we're passing it. Oh my god, I hate that. Yeah, I don't like that. For enumerate array, index an element, because we're enumerating an array. I mean, you can do the same thing. You can do the same thing in Rust. It's more just a question of why the fuck would you? Also, tuples are not very nice. If I 3, then continue. If then break. Wait. So continue and break use a loop effect, which really means break early effect. Nah, that's really messy. I'm not a fan of that. It doesn't even make it like it doesn't feel intuitive or idiomatic. Occasionally, it is natural to reach for a recursive function. Don't say that. Go numbers total, match numbers nil, cons x-axis go, x is total x. I really do not like loops, man. But this can be cumbersome when you just want a quick loop in the middle of a function. For this case, Ante provides the loop and recur keywords for creating an immediately invoked helper function. That's cool. The following, if you want to use recursion, but I don't want to. The following direction of sum is equivalent to the previous. So loop numbers total equals 0. Why are there so many different ways to do loops in this language? Match numbers, nil total, cons x-x's, recur x's. This actually raises a decent point, which is lambdas cannot be recursive because they can't call themselves by name. Has anyone ever noticed that? I mean, actually they have. So what I'm thinking now is you actually do allow functions to have names. Let me just delete these. Well, that's weird because this is a type annotation. It's like FN with a capital N. F. Then. Yeah, it kind of have to be then, wouldn't it? Anyway, so FN, and then give it a name. Like FN go, for example, which allows you to call it recursively because it has a name. And then because it has a name, you can assign it to another name. Question is, why would you do that, right? I don't know. So what you can do is have declare add declare function add AB, let's just ignore the types for now, returns, yeah, I said ignore the types, didn't I? AB, A plus B, right? So and then a variable the issue with this is it means that you can just declare an empty function name, which to be fair isn't like a bad thing, although it kind of is, because it makes no sense. I declare this anonymous function. It's like, okay, cool. Nah, this isn't clicking. Anonymous functions do not need to be recursive, I think. I think it's a very minor thing. Just give it a name. Like, declare it explicitly. I don't know, man. But anyway, I don't like recursion. After loop keyword comes a list of variables / patterns, which are translated into the parameters of the helper function. List as an int, get digits as an int x, list as an int ret. Is this C++? Yeah. Get digits. Loop x. We got nil. That's weird. Nil for digits. What is digits inferred as here? It's the return value, right? Kind of weird how we call it ret here, but digits here. It's a bit goofy, but okay. Maybe a bit more consistent. So it's a list. Yep, but it's like we don't make that very clear immediately. But okay, digits equals nil. Nil's an empty list, I guess. If x equals 0, then return digits. Last digit equals x modulo 10. Recur x over 10 with last digit onto digits, because there's no cons syntactic sugar or operator. Goofy how we have no space here but have a space here, by the way. Just another reason why you shouldn't use colon, because it doesn't look nice. Cons, last digit, digits. Here, while I does not equal 0, do this. I mean, a while loop is just a, well, yeah, it's conditional. Like it's a loop that has an if statement inside it, I guess. You could say that. So while x is not equal 0, last digit equals x10, return dot push front last digit x equals 10. I mean, this uses, obviously mutability, right? Whereas here we are not using mutability, we are instead recursively doing something. So we're returning it and updating it through recursion, which is different because it's calling itself. I mean, look, I prefer this. It's just easier to read. Oh, my voice cracked. It's just easier to read. Even if you like got rid of the while and like had loop instead, like, and then you just put like if I like have had the if statement here, like it would reach largely the same. The main difference is just that this has mutability. So it's like each step we're pushing front, then dividing x by 10. Whereas here we are constructing a list by adding x over 10. And then like passing that into the next loop iteration of the function. Like it's just harder to like process. Like maybe you can with experience translate this and make sense of it. But like you make sense of it by translating it into this. So like just write this. Like I don't like it's a good way to avoid mutability, I guess. But like doesn't it compile down to mutable state anyway? So like if something is so decisively going to be mutable, why not just have mutable state? I don't understand that. Riddle me this. Pattern matching on algebraic data types can be done with a match expression. Since match is an expression, each branch must match type. Yeah, but the value of match branches eventually becomes zero. Okay, know that if antivariables must be lowercase, they must be lowercase, while type constructors are uppercase. Yeah, good. Well, there's something uppercase, all caps, uppercase, whatever. This carries over to match expressions where each uppercase word is a tag to match on, while lowercase word, while each lowercase word is a variable to bind. Bar is unused. So I'm guessing you can just do some underscore then. It's kind of weird. If a variable binding is created but otherwise unused, yeah. If a type has many, well, I guess it's like if you want to, right? Okay. If a type has many fields to match on but several are unneeded, they can be omitted with dot dot. So no underscored is dot dot. Fine, just same thing, different clothes. Foo I32, bar 32, blast I32, cucks. Cukes, I haven't seen that before. Okay. As seen above, structs are matched using positional argument order, similar to how they are constructed. This may also be matched by field name using the same with syntax for named struct field construction. Fields can be renamed. Why would I do that if this is already a binding? Oh, it's like specifically the structs. Okay, sure. In addition to the usual suspects, so union checks and pairs, we can also include literals and guards in our patterns, and it will work as we expect. Note that there are a few such design decisions. All type constructors must be capitalized. They already mentioned this. Each pattern is prefixed with this rather than being indented like in some other languages. Holy voice crack. Doing it this way means if we indent the body as well, we only need to indent once past the match instead of twice. Yeah, that makes sense. Just to be a second to process that. Oh no. Oh no 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 no. Oh nay 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 nay. Oh nay 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 nay. Why is there an is operator if there's already a match? Riddle me this, Joker. Batman. The is operator can. Bro, is it like a fucking GTA outside right now? The is operator can be used to pattern match within arbitrary expressions. The syntax for an is expression is this. These expressions can be used to test an expression. If an and is used after the is expression, any variables defined in the pattern will be in the scope of the right-hand side of the and expression. So if e is int x and even x. Is even. Huh? Well, why do we call this is even int, but this is just called even and not is even? That's a bit weird, isn't it? Note that because expression. Also, I do wonder, by the way, if even is keyword, you can do e is int, right? You can do e is 5. But what about if I want to do like e is even? Can I do that? E is even. Or even is a type. I guess you could. Like e, like the even type would just say e must be an integer first of all, and it must also be even by following this requirement. So I could say is like e is even, right? I could say that. That would be interesting. Let me see if I can prototype something for that. Prototype something for that. What is going on outside my window? I saw sausages. So I don't know what you call this. Let me just write it first. So we have a trait. No, a type, sorry. So type what is the type? What is the type of a type? Type. Right? It means you can't call your type, but that I don't think is ever an issue. Well, no, because you won't have like foo type, right? So you could make it a keyword like type instead. So foo even type equals or TP even for type. Like fn is a function and fun it's like that. So you can have TP. I'm not speaking clear at all. I can have TP for type. So I have like a TP. Really, it should be a keyword, right? I'm experimenting with this idea of what if keywords are all uppercase, like sorry, all caps, because then you don't have collisions with identifier names. Of course, you could make them depend on where you put it, but like have soft keywords. Yeah, having uppercase everywhere just like looks really ugly, doesn't it? So let's just have. Yeah, whatever. So anyway, declare even. I want to also experiment with this having the declare syntax again. So let's say we have a type, right? So declare even, which is of type. And we'll make this lowercase now. Because like also if they're uppercase or like all caps, it's less so that they're ugly because like they are, but like they're ugly because they're distracting. Like if something is in all caps, it draws attention to it. But you don't want to draw attention to keywords. Like you don't care about keywords. They're more just background noise that make things easier to parse. Like both visually and literally. So you don't really want to do that. So maybe functions and variables should be Pascal case, but then types should be uppercase. How about that? So if I want to have I don't know, like a player, like player would be all caps. So player, right? Like this. So declare player. Yeah, I'm playing. That's what I meant. Okay, declare even at type equals. So how can I do this? I could have TP again for type. So type, or just type even. But like I've FN for function. So like TP for type makes sense. So let's have a type, and it would be integer, right? So type, and it would take in a parameter, wouldn't it? Like type x. It's a variable. This is actually quite interesting now. Types. Let's cruise at it. So we have a type x, let's say, which it takes an x and it returns a boolean. First of all of these types will return booleans of some sort, kind of. So we have type x, which is integer, integral rather. That's right. Type classes don't work well with traits, do they? Because traits are functions, whereas type classes are type classes. Yeah, I need to look into like set theory. Really, I think it's a bit different. For now, let's just do it like this. So I have a type t, where type is integral, right? T is integral. So we have t. I just realized I used a colon for this. It should be an at. So xt, and it returns, it checks if x modulo 2 equals or is 0. Or just more idiomatically, x is divisible by, and that is a trait of integral, so that's fine. X is divisible by 2. So here we have declared a type called even. So declare even, which is a type, equal, I mean really I don't need this because it's already a type anyway. Type, taking a t thing, right? And then you just do the same thing. So then I would like declare x, right? Declare x as a even. No, it is equals, oh no, 8. That makes sense, does it? No, that does not make sense. It should be a trait. It should be a trait. I don't know why I said type. So if it's a trait, it's different. Okay, what is a type? A type is like U32. But like a type contains data. That's different. That's different. A trait is simply an interface. The thing is, even you know what's weird? There isn't a integer trait in Rust. Let me cook. Declare x even equals 8. Now the thing here is if I put like 7, then this would give me an error, right? Because it's not. So like whenever I assign here, the compiler at compile time as part of the type checker will check this condition, and if it is, then it is fine. If it's not, it will give you a compiler error. And if I pass a runtime variable, then likewise it will give me a compile time error if I do not prove, first of all, that it isn't even. So like let's say I want to assert, or like assert that foo is even, then this works. Or better yet, like handle if it's not. So like if foo is not even, then like return, right? But for now we'll just do this. So foo is even. Likewise, like foo is integral. Like you can put type classes here. So it accepts both types, like foo is int, foo is 5, like these literals. Foo is foo, foo is integral, and foo is like U32. Very interesting. The is keyword can be very interesting. I want to propose a few things here. So is keyword, or is operator, it's better. So I mean, like it is a keyword, but like its functionality is as an operator. So we have simple case, right? Foo. So let's say we have like x, right? X is declare x as a U32 equal to like 5, right? So we have x is 5. Okay, x is not 3. I will declare y as well. Declare y, which is a, let's say an I16 equals 7, whatever, right? X is not y. Actually, I'm missing U32. So x is y plus 2. X is not y. Right? So I'll put it in asserts even. So that you have those, you can just say x is. Now, do you have x greater than 3? Or x is greater than 3? I'm a fan of is just generally being used to evaluate Boolean expressions. I am a fan of that. Like whenever I have a Boolean thing, I put is, right? But then like x should like quit, right? That's different though. So I guess like that's the exception. Like x is should quit, right? Like that doesn't make sense. But like generally speaking, unless you're doing a function call that returns a Boolean, you use is. So x is greater than 3, right? X is less than or equal to 5. It's true. Yeah, but x is not greater or equal to 7. Greater than 7, sorry. I can assert that x is, and then like I can have another one. I can have of U32 for types, right? X is of U16, U64. Now this works because you can implicitly cast it. So because since U32 is a subset of U64, okay, this gives you an idea. Assert x, this isn't the idea, I'm just continuing. X is not of U16, since U32 is not a subset of U16, and x is integral of the integral type class, right, or integral trait. How would you do type classes? I feel like those should be separate from traits, because traits just give you functions to implement. A type class needs to say you are of this type if you are this type, this type, this type, or you satisfy these requirements, right? Okay. So let's assume that traits and type classes are different. So we'll have a type class. Now for traits, like x is addable. Now here you can have x can add, right? Now the issue here though is that I know it reads like English, but we have removed the is keyword. So now now we're using a different operator which says can it do something? Like does this inherit this trait, this ability, right? Whereas this says is it something? Is it 5? Like this is structural, this is like ability wise. I mean you could have them be separate, right? X can not. Well, that's from like cannot. Again, English just being fucked for no reason. X can not add. Or you do like X is addable, so then it would like include these things. Addable though. Addable. Let's assume you have these abilities instead. So you have integral, you have add. So X is I mean like able to comes to mind, right? Able to add. X is able add. But that doesn't make sense. X is add able. Yeah. Unfortunately, you're going to find limitations with the English language where you almost wish you had your own grammar. So we have the of keyword, right? X is of U32. And the reason that I had an aha moment is then I could actually have it be like this. So like declare X of even. What? Even's a type class, right? If even is a type class, also can type classes have functions? I guess addable is a type class, right? So let me think, instead of type classes, let me think about sets. all integers fall into the set of integers, right? The integral set. Likewise, they all fall under the addable set, the set of addable numbers. So really, you would have something like you would check, like, does x have the ability, like, have this function, basically. Like, you structurally check, does x have this function? If it does, it is of the add type class, right? The addable type class, which is very interesting. But then we're not implementing it explicitly for add. We're just saying, do we have this function, which is different. That's different, right? X is integral. Yeah, so addable is a type class. Let's suppose, right? Of the addable type class. But what that means is that if it is addable, that it must contain, like, if I create an interface, right, for addable, then, like, I'd have, like, a function add, right? So declare a function add, yeah, declare add of type function from, I don't know, just like just t to t, I guess. I just realized you can't really enforce that it actually adds, doesn't it? But anyway, so let's say you have a function of from t to t, and t can be anything, like, it doesn't matter. And returns t. Well, no, returns type of t plus t. But that assumes that you can add them in the first place. That actually creates an interesting problem, right? We actually need two type parameters then, t and u. So we actually have u as a return type. Also, who says it has to be t and t? Well, what if I want to add t and u and get w? Interesting. But this says that I must be able to add to other types, which isn't really what you want. So really it should be interface addable t, and then we take the t from there instead. So a normal function, but we have a t to t to t. And, like, plus is already built in. But yeah, I mean, you can't. That's the issue. You can't have the return type be the same per se, right? Like, maybe I need to grow the type, so I change the return type. if I have a U8 plus a U8 and I add them together, do I expand them? To be fair, no. I would just overflow. Or like expect an error. I would expect an overflow error. And if I want to avoid that, I need to set the T explicitly as U16. That's fine. Okay, anyway, sorry, this is not related, really, but like, let's just go with this for now. So we have an interface T. But that's an interface. Like, it's not a type class, but it is a type class. So really it should be type class. Whatever, type class addable. Which we'll call trait for now, because that works fine. So we have a trait addable, right? And then we could have implement addable for like U8. Or impl U8 for addable. Why is it like that? Implement addable for U8. Implement U8 at addable. I don't know. So then we have declare add. Do I even do add, or do I just do add equals? Well, no, because we're declaring it. So declare add equals a function U8, well, self, let's say. Yeah, so it'd be an anonymous A of type self and anonymous B of type self, returning self. And then I define it as A plus B. I mean, shocker, I know, but like, and yeah. I mean, this is a terrible example because like it's built in, but or okay, a better example, a vector. So so let's say I have a vector of type T. So I'd have T, is that right? Yeah. So again, anonymous A and B, that's fine. But it would be I don't know, like a vector from vector new. I don't know, whatever. Vector make, vector create. Vector creates a dot x plus b dot x a dot y plus b dot y. Like, let's say we have this. I hope that's correct because my brain's like barely functioning right now, but yeah. So I have a vector and it creates a new one using this, right? And you replace the of with at. But then, now we want to look at the integral, right? Integral isn't a trait. Like if I have trait integral, that doesn't make sense. It's like a set, right? It's just weird because like it's weird because like they are sets. Like x is part of the integral set and parts of the addable set, but the way you implement them and define them is different. It's like they are both sets, but they're just different. Like integral is strictly a set, right? So integral is a set of oh no, of t's? No, like it's just I don't know, it's a set satisfying this, right? Like even is a set. But I've called it a type, but it's not a type. It is a set definition. So let me leave this for now as it is, but let me have like, so I have a set integral equals a set integral taking a x where x is like let's say u8 x is at we'll use like dot syntax, I don't know, u8 u16 u32 u64 i8 i16 i32 i64, like let's say it's like that, right? It's integral. So I should probably explain what this does is it just puts like an or between all of these basically. Yeah. You could like x is one of, I guess. But I mean, let's just assume this is valid for now. So x is u8 16 32 64, and instead of commas let's do this. Okay, so x is one of these, right? So x is one of these. Yeah, and that's it. So like we have a set. Now I don't like how set is. Like it's like I'm set integral. Like set the integral. Like no, that's not what we're doing here. It's just called set. All right, category. Let's call it category for now. I feel like that's just a bit clearer and harder to confuse. I know it's called cat, which could be confusing, I guess, but whatever. So category integral is this, right? So very different, but they're both sets. Like you get what I'm saying. I guess the difference is that you can compose sets from other sets. Like I could combine the integral set with the, or rather I could, I don't know, like I could combine the even numbers set and the odd numbers set to combine them and get the what do you call it, the unison, the unites. Like I can combine them basically to get the integral set. Like if I have my even integers set and my odd integers set, combining them I get my integer set, like overall, right? So they are composable in that sense, whereas I can't like compose my integral set. Well, no, I can though, because I can have my integral set and my addable set, and then combined I have my set of addable integrals, right? Or like addable integers, right? So maybe combine these. So I have a category of addables, and in this case they can have a thing, right? So I can have a require keyword. So require that x is this, and then decl says just declare. So I can declare functions for the interface and also require these, right? So require x is this. You could like require decl, I suppose, but I don't know. But something like this, right? Require. Just ignore the names for now. So I have a category addables, and I can also implement it like this. So require this. Require that x is addable, right? Because it's an integer, for instance. Oh, this is actually kind of fucked. I mean, like in an interesting way. So here I'm using the dot syntax. Okay, the ellipse syntax, ellipsis syntax, the 3 dot syntax, whatever, to say that x is either one of these, and if it's one of these, it's either one of these. That isn't too confusing, is it? Like you see the dot here, and then you see it here, and you're like, okay, fine. Like you can kind of fill it in. Like I feel like your brain's pretty good at like seeing a dot and a list and going like, okay, just repeat this for each one. Right? Like your brain's pretty good at doing that. So I feel like that's clear enough and takes like 2 seconds to get used to. But what if integral is simply a collection of possible types? Or is that not a feature? That's needed. Like C++ standard integral. Right? Am I tripping? Like, I notice how C++ has standard integral, but Rust doesn't have a direct equivalent. Instead, having add and whatnot as traits. Hold on, how is C++ standard integral implemented? Holy moly. Wait, it's not even a concept? It's a struct. Right, it uses is integral v. Yeah, C++ has a very funky way of doing it. But like, it is there. Like it does exist. It's just that the way you do it is really funky. In my case, I wouldn't use structs. I would just have it as like an actual function, and that's really the only difference. And the function is called implicitly here, require, and then you just put a boolean here. That's it. Similar to how you have concepts. I mean, concepts literally are the same, right? Concepts literally say, okay, there's no require, I guess, but whatever. Like this is a boolean, I think. Then we know when to use it because it have no methods you can call on it. Right. But what if I want a function that simply just accepts integers? Like if I'm writing a library for, like, yeah, if I'm writing a library for serializing, I don't know, like JSON data, I want a write write t I want a write that only accepts integers. And that's a pretty simple use case, right? How does Rust do that? How does Rust go about this? I'm aware it doesn't have an integral trait in its standard library. What if I wanted to target all the integers? Like if, yeah. Unless I added one, but I would be surprised. Define your own trait. Ah, that's weird. Right. So the macro that Claude gives me is necessary. Um, you just it just makes it faster, I guess. That's so. I don't understand why languages don't have this. Like I use standard integral all the time in C++. I don't understand why you wouldn't have it in Rust. Why? Yeah, why? I don't understand. I think the reason that Rust doesn't have it is more because it doesn't want to do it. I don't really understand. I never really understood. Okay. I'll do like Rust, I guess. Auto, no, function. So let's say I like ever write num integral, which is of type T, right? And it just like, I don't know, file dot write integral dot toString. In the meantime, so if I want to compose categories, I could have like category addable integer or type class addable integral equals integral plus addable. I just realized I have a t here, addable t. I guess I wouldn't have t. I just have like I can't speak. I'd have self, right? Self to self to self. Yeah. What if I wanted to have further restrictions here? So it equals an integral plus addable and I require like it's even or something. I don't know. Yeah, this is like this is not a thing in C++. Like, this isn't an issue in C++. I don't understand why this is an issue in Rust. Okay, moving on. So yeah, so both are sets, they're both composable. I just needed to think of a way to unify them, their syntax, and this works. So you have a require. Actually, this syntax here is very similar, isn't it? I said like equals like U8 plus U16 plus U32 plus U64, right? In fact, I can just have this plus I64. If we assume that a U64 is composed of U8s, like it has those subsets, then that's fine actually. Just do that. Right? So you say equals for like what it is. Oh, but I want like further restrictions, right? Like not just what it is, but what like it. Okay, so in that case, the other way is keep this, remove this, remove this, and have it instead be require is. Also, I don't know why I have x there, because a type can only take one parameter, right? Like it's not like a struct, like it's literally just a type. Like an array can have two things technically, because it can be like a type and a size. It would take a type and a size, right? But that's not a category, that's a struct at that point, which is different. So is it actually? That's actually interesting. So now we have structs as well in the equation, and that makes things more interesting as well. I mean, these are categories, right? A category is not a concrete type. It's not a concrete type. I need a toilet real quick, but let me think about this. It's been like 4 hours as well, but Um. Um. Did I even think about it? Oh my god. Got some food here. As well. Yum yum. So hold on. How does that? How's Haskell do it? What? I barely used it. How do? Right. You leave me no choice. How does Haskell implement its integer type class? Oh yeah. So Haskell has a what? Haskell has them as separate then. But when you declare an integer, you don't have to like specify which one it is. Or do you? No. So it's syntactic sugar. It's weird. That's really weird, actually. Hmm. Okay, it's weird that I can't think of a language that that does this properly. Then, I mean, I guess C++ and Rust do, but they're just a bit like unconventional. Not like sorry, not unconventional. They're just like a bit, well, a bit verbose. Okay, so this is dumb because there's no thing. But like, let's say we have cat. I'm trying to think. Do I use a type or a type class here? I think type class makes sense, right? Like a type class, it can be composed of types. A U64 isn't composed. So okay, so the difference here is an integral type class is just one of these, right? For a U64, the reason a U8 is a subset of U64 is not because U64 is a category that is made up of U8. No, it's more just that U64 has a non-narrowing conversion for U8, so that you can do U64 from a U8, and because it has that implemented, then it's the same. So I can do this. Require is this. And let's kind of simplify this. So at U64 and at I64 at big int and at addable. So what this means is that you're able, well, that it is one of these types, or it can cast to one of these types. Like there is a non-lossy, specifically a non-lossy conversion between these two things, right? And what that actually does is it allows you to simplify, to just begin. Right? And big int already like inherits addable. So that's it. Just require that your thing is a big int, and it could be one thing, so we won't have that. That's it. Right? The issue is that by that logic, booleans are also integral. They shouldn't be. Because like you can convert a boolean to an integer, right? I mean, you can. It's interesting. Like, there needs to be a way to say that one type contains all the values of another type. Therefore, it is like a superset, right? But like the exact same characters, like values. So like they map perfectly, right? So like a boolean doesn't work because, you know, true maps to 0 to 1 and false maps to 0, but that's those are different values. Like the type changes. Whereas U6, like a U32 to U64, everything maps directly from the U32 to U64, right? So it contains that. But that's really hard to kind of pinpoint, isn't it? So assuming that that is the case, then I'll leave this as it is. But it means that like there needs to be some kind of way to express that the mapping is 1-to-1, and like each value maps to itself, right? So like you literally have like the identity. How do you show that 1 as a U8 is equal to 1 as an I64, right? Like, you can't compare bits because bits can be anything. Like, the same bit for 23 could be the character A, right? You can't compare. Eh, that's just, yeah. This is actually really interesting. So, how do you prove? Like, how do you show the computer that like a 4U8 is equal to a 4I64, right? Like, we can see it, it's obvious, but like to a computer, these are completely different things, right? Like, these are no more similar than, you know, 1 equals true, right? So how do you tell the computer this is not valid, but this is, without having like you know, but like within the language? Okay, I mean, yeah, like I don't know. I mean, it doesn't help that the integers are primitive types anyway. How do you interpret integers actually? Like, what mechanism of the computer does that? Because like, you never, like, when you think, oh, how do I implement characters? Like, you think, oh yeah, I mean, like, it's just ASCII, right? Like, or Unicode, like it's just numbers, and that's fine. Or booleans, you know, like, yeah, under the hood, you know, there aren't any booleans. It's just 0 and 1, you know. And strings, you know, like strings are again characters, which are numbers, and you give pointers to the string. Any like enum would also just be an integer. Like, everything is ultimately an integer. But like, what? Like, when you use assembly, you don't actually work. Like, you still use integers. Like, what part of the computer reads the 8 bits and says, or the 8 bits, like reads 8 bits and says that's 4, and then tells you that's 4. Like, is that calculated? Is it like, is it just done? Like, I don't know. What if I wanted to add up the bits in a different way? Like, how would I do that? And then again, like, how does the computer know that 4U8 equals 4I64? I really don't know. I mean, sure. Just say that like I don't know, some type U64 is equivalent, or like is okay, better. U32 is a subset of U64, right? Fine. U64 is a subset of big int, right? But my problem with this is that it is explicit. Is there like a different way to say this, or like, sorry, or like a way for the compiler to just know this? I guess not. Or like, you would want it to. And like, this is only assuming I have like a U64. You know, like a type like U. Again, I'm using array syntax for the argument. Like a type U. I don't know. N, right? Which is N, no case. Is a subset of U. Sorry, N plus 1, or N minus 1 for that, right? Like, can you communicate that? Like, surely that would make compilation so slow. Or like un is a subset of ux if x is less than n. Sorry, if n is less than x. Or equal to, right? And we'll say n. The irony of that is u size, but like u size, right? So can I do the same for categories? Like, what is a type? Right? Like, generally, what is a type? A user-defined type is a struct. Literally. And a primitive type is not a struct, it's just built in, right? And has, like, sugar to make it work differently. So you can have a type. Let's say I want to define a custom thing, right? So let's say I have a type, my int, right? I don't know. And like, let's say it has a variable inside. Okay, you know how a constructor can fail? Wow, this is a lot to think about. So, like, let's say I want to have an even number, right? Is even number a type or a type class? It's probably a type. But it's a templated type because it can be anything, right? It can be an even I64, an even U64. Yeah. But ultimately, it would have to be a type. So what makes integral not a type? No data. Yes. Okay, I see. You can declare an even x, right? Like an even integer x, and it is an even integer, right? Like it is of the type even integer. But if I create an integral x, that doesn't make sense. Like, yeah, x is integral, but like, what is it? Like, is it an integer then? I mean, obviously it is, but like, which integer, right? I think what I'm saying makes sense. So a category can, first of all, give you functions you must implement, right, like an interface, and it can also require certain types, right? Like it says, like, yeah, T has to be like basically satisfy these requirements, and the requirements are either must implement my functions or must have these other requirements that I set arbitrarily, which is here, right? Require is big int. A type is different. So let's say we have declare even as a type, right? Yeah, so even is a type T, where T has to be integral. Okay, and then we say X, and then then this here is now the constructor. Okay, so let's say it takes yeah, just our thing, right? So it takes an anonymous X of type T. Okay. That doesn't work, does it? I mean, like, it does work, but like, where's the how do I declare like the struct members? No, you know what? This is not the constructor. Okay, let me just drop down like force the syntax and let me just do it properly. So we have a type, even, right? Even numbers of type T, where T is integral. Yeah. And it contains the members, well, just T, well, X. Declare X. I don't declare. It has X of type T. Private by default. Yeah. So. Yeah, and then we need constructor. So we'll have new 0def, by the way. New equals function X. Again, it's anonymous. Let's suppose we have an explicit. Well, no, it's static, isn't it? So it's a static constructor. So it'll be. What do I do? Static new. I think so. I like the idea of having static. rather than like because like in Rust you have implicit static functions, if they don't have self. But I'm not a fan of that. I'd rather like have an explicit static that says this is the same across all classes instances, right? And like same goes for variables. I mean, in Rust you can't have can you have mutable struct members? No, you can't have individual mutable struct members, which I think is really weird. So static new is a function that takes an x, right? So what's conventional? New x? I don't know, man. Just okay. Anonymous. Hold on. You don't need an anonymous keyword if you have underscores. Not a bad idea. Okay, let me go with underscore x for now then. So underscore of type t, obviously, and returns self. Okay, and it will simply just be if x modulo 2 is not 0, because here there's no not equals, it is not 0. Then return an error. Okay, in this language, everything is errorable, for the record, such that everything is an optional type. So like this is already self or error, okay? You just don't have to like make it explicitly called self or error. So return an error. I like a lot of conflicting ideas right now. I mean, how do I even construct in the first place? So like if I have like, do I return even constructed with x? Like I can't do that if I don't allow brace initialization. Well, actually, I guess I don't need to, do I? I just call it even new on x. So I should be create. No, actually no, it should be new. Yeah. My issue is that new isn't a verb, but in this case it's a special constructor. I mean, you could call it like construct, but or I guess construct would be better. Hamilton. It's starting to look right. It's just a question of how the fuck do you actually return. I mean, I can just like return even, where x equals n² x, right? But then, but I don't want my language to have that syntax. I want you to be forced to use the constructor function, right? Similar to how like in C++ you can also delete the default constructor or override it or like redefine it. Of course, what you can do is just do so here it's in an uninitialized stage. Actually, I should require this first, right? So require that, then say even. Sorry, is 0. It's even. Even as well. We declare result as even, and then result dot x equals this x, and then return result. Right? But it'd be nicer if you could just do result implicitly, so that I don't need to do this. I can just do this. Like, there's not really a great way to do that. Like, I can do like results here. I can, right? Like, why not? Yeah, fuck it, why not? So, the reason I don't like, okay, the reason I don't like the underscores here is that it just looks really bad in the code to have underscores. Just click a non-new x. Or x new, x2, x new, I don't know. No. Really, you want them to be the same name. So we'll do X. And we'll just require that if you want to access these, you must do self.x. And then this just resolves the argument name collisions. Because it's just not really possible to do otherwise in a nice way. So, and that's how it works anyway, because it is like that. That way, the only way you can have a collision is if you have this be static. Actually, I guess there is another way to get around it, which is to prefix this like member underscore x or something, right? But I really don't like that. Yeah. You should need to. So, okay. We've done this. Now what? Okay. I'm gonna keep this for now, but really the way the way you would do this is you would declare this is a type, so you declare x, right, as an even u64 whatever, and say it equals 8. Okay. If you say 7, this is a compile error because the constructor requires, right? I'm just realizing this is new, so actually it'd be equals. Ooh, this is problematic. Yeah, this is actually kind of bad. Fuck. Okay, so now we have this problem, where you can do this in theory, or you can do declare x equals even u64 new 7. Now ignoring that one is more verbose. Well, yeah, one is more verbose, right? I think it's fine if I think it's fine if no. Okay, so in C++, constructors can implicitly accept values like this, right? Or you can explicitly equal the constructor. You can also disable the ability to do this using the explicit keyword, I think, or something along those lines, right? And that forbids this. So the opposite would of course be implicit. So static, implicit, new. And what that does is it lets you just do this. Furthermore, it forbids this, maybe. I don't know. But because it's implicit, we can do this, right? And then to access it, we do x.x. I'm kidding. This is private, so if we made it public, then it would be x.x, right? So that's the issue there. Now, alternatively, the way you would do it so that you don't have to have it wrapped is type even, still t integral. That's using the wrong syntax. And then type even of t integral has no members. So it'd be even, x. Here the name is truly irrelevant. Okay, this is a one argument tuple, and here's why. I have x of type t, and it requires that x 2 is 0. But it's not over 2, but whatever. So what's different here? The difference here is that this takes the constructor here, and therefore x is treated as an implicit access, like x, like it's like an alias kind of, except you can add requirements. I also wouldn't add this, so it would be like this, and then you can have declare x as even. Again, same thing, just u64 equals 7, right? And then it's just x. Your phone call? Oh, I'm missing the game. Just realized. God, it's been so long. Portugal versus Spain. So 0-0. Who the fuck just called me? One second. One second. Five-hour stream. Yeah. I need to check into my flight. I just realized. Well, mind you, it's actually not for a while, but I do need to check in at some point. I'll to forget that. Nothing beats a Jet 2 holiday. Yeah. Okay. Was that 10 minutes? Dude, time is flying. I will miss the Portugal-Spain game, but to be fair, I don't really care that much anyway. I'm fine watching the highlights for that. Here's Ante, right? Yeah. Right, so as I was saying, you can just use it. So print x, and you can just print x.x. Okay, I'll just assert, whatever. So assert x.x equals 7 is 7, and x is 7. So obviously, both of these are not equivalent. This is not just syntactic sugar. This is literally a type like direct type. You could call it that. Whereas this is a wrapper type, right? So it's different. What the fuck? Okay, so yeah, it's wrapper types, like wrapper, even, right? Whatever, like it's that. So that's it. That's it. And then I can make this one line even. Yeah, the reason that this is because operators have no precedence in my language, I've decided. Now, whether I extend that to is, I'm debating. I could have is be the exception, since it is a keyword, and just have it like this. But, I don't know. But, yeah, anyway. Oh, so this would accept any const x per function, so I could also just do requires x dot is divisible divisible by 2. Pretty cool, right? To that end, I could even just do, well, no, let's not complicate things. So then, yeah, have a function as well. Why not? So I declare a function. Declare. Oh, actually no, it depends on x, doesn't it? Okay, let's assume that x just, implements that. So require is a keyword. Assert is also a keyword. Promise is a keyword, but requires is another one. Requires just says, or even require, sorry. Requires says that if code execution reaches this point, then this must be true. And it must be proven by this point that this is true. And that's basically it. Pretty damn simple. Yeah. So I'm only keeping this because I need to remember this syntax, but this is this is what I was getting at with the types there for even. So that takes us back up to here, right? So x is integral, x is addable. Then you do assert x is type even, and that's different, right? So even is not a trait. Even is not a trait, because a type class is for types, right? So like, would you have even types? Like you could, but like no, like not really. The even, like really, it's even integer, right? Like that is the full name. So we say x is uneven integer, right? X is a even integer. It is of the type even integer, and that's different from these, which are type classes. So pretty straightforward. You may argue that it's not nice how type classes have the exact same casing as types, but that really shouldn't be an issue. Like, is even a type class? X is integral. X is even. And like even means something else? I don't know. Probably not. Like, plus type classes can be context sensitive. It probably shouldn't be, but like what else are you gonna do? Make them all caps? Like you could. So like it's like integral instead, and X is addable. Honestly, not a bad idea. Okay, honestly, not a bad idea. I might consider it. So categories are all caps. So you get this. This isn't right though. T at integral. Because this means like it is a type. Well, no, because a type class is like a type of types, right? So like it does make sense. But like, how about higher order types? You know? So like types of types of types. How would that look? So like for addable, say instead it was a higher order type. So you have type addable, just like you would with anything else. Okay, so like let's say I have this right now, right? So I have type addable, and it has a function called add. Yeah. a function called add. Hold on, how do you declare a trait in Rust? I just realized I don't actually know. Oh, fuck's sake. Okay, Gemini. Actually, not in Gemini. I just Rust create define trait. I can use Google for this. Right, so it's literally just a list of functions. And then you can input animal for sheep. So. Oh no, it is the type class first. I didn't realize that. Okay, or the trait first. So. Let's suppose that our trait was just this. So we just add. And. Add equals. Function. No, add of type function self to self to self, and then there's no definition. So what this says is that it has this function, but it'll be declared elsewhere. And okay. How do higher order types actually work? Because an object is not a type, right? Like 5 is not a type. It's a value. With higher order types, you have the ability to treat types as values, but like types are fundamentally different from other values. Like higher order functions work because you just treat functions as values. Wait, higher order functions work because you treat functions as values. So if addable, the type addable is a value, I can pass it around. But types are different because, like, functions are instructions. Let me see if there's like a video on higher ordered types or something. Higher order types. I mean, I'm not even sure what that necessarily useful for, but it's just like having a kind. A kind is the type of a type constructor, or less commonly, the type of a higher order type operator. A kind system is essentially a simply typed lambda calculus one level up endowed with the primitive type. Examples. The kind of any data type, which does not need any type parameters. So it's like T, but just without any type parameters. It is the type of any data type. What does that mean? So K is just what? Because he's wrong. String is a type and int is a type. Higher kinded type. Monad? Is monad a higher kinded type? Think of functor. Functor gives... But functor is just a trait. It's a type class. Yeah, that's different. That's a type class, right? Yeah, I think I understand that correctly then. So actually, no. So fuck that. So what I want is a type class of type classes. So I need to ask AI for this one. It's quite specific. So an object has a type. A type belongs, well, can belong. Okay, an object can belong to a type. A type can belong to a type class. What comes after that? What is the class of type classes. Kinds of universes. So values have concrete values or objects, yeah. Types describe collections of values, right? Yeah. So then you have kinds, the type of a type. Maybe it takes a type and returns a type. Does it? Maybe int. No, yeah, that's true. So type classes are a kind, but they have a constraint. So constraint is a type, type is a type. Impure type theory universes. So let me just think of like an example here. So if I have a type, like I have my type addable, right? Which is a trait. So it is a constraint that my things can inherit addable, therefore they must be addable, right? So then what is the class? Like what set does addable fall in under? But no, sets aren't the way to think. Well, they can be. So I have 5. Okay? 5 is in the set of, I don't know, like set is in the, what, 5 is in the set of 8-bit unsigned integers. And 8-bit unsigned integers are in the set of integers. Because integers I mean, at this point, we're still talking about values, right? So therefore, 5 is an integer. Now, if I say that integers fall under the set of addable numbers or addable entities, right? Then I have my addable entities type class. At what point do we cross from a type into a type class? Constraint. It must be, right? Because a normal type just has values, like possible values. A type class has constraints. So it says, I will accept these values if and only if this. In the case of programming, you have functions, right? Because of object-oriented programming, you have functions, or they can be used with these functions, right? So it's constraint. So why are they syntactically different? So can I go further? Like you could say that the addable trait, therefore, like so the set of addables is a subset of the set of numbers or like entities that can undergo arithmetic operations, right? But that's more like of a composition, right? Like addable can be composed with subtractable and multipliable and divisible to get another one, which like is still a type class, but it just has like compounded constraints, right? So I guess the question is, can you constrain Can you constrain a type class? How would that work? You can only constrain in this way. So like addable is only a no, my mind's actually blank. I say the constraints is what makes a type class, but that's not really true. Like even numbers are not a type class either. They're just a thing, right? It's more that they're all constraints. Like an 8-bit sized integer, an 8-bit with integer unsigned, is constrained. It constrains you to the integers from 0 to 255. Right? So as you go up, the constraints actually get weaker. Like integers accepts all integers, and then all addable entities. So it can be any entity, it could be real numbers, it can be imaginary numbers, and it could be strings if you can find a way to add them, right? Well, I'd like to add them in a way that conceptually makes sense. I guess that's not really necessarily easy, but it's a thing, right? And so what's the constraint after addable? Just the anything, right? The any type. What I'm getting at is that a category isn't any different from a type. Like the way I have it set up here, where I have category integral but type even integer, like really these should both be types. This is wrong, by the way. This is not even mathematically correct. Like this is a struct. And structs are different because structs a struct is a product type. So if I were to write this like truly, it would be more like this, a tuple, just with like an unnamed argument. Right? I'd have an unnamed argument x, and because it's unnamed, I can just access it directly. No, 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 no. It's just a value. It's just the set that a value belongs to. A struct is a product type, but a product type is a whole different story because, like, the product type that is like, I don't know, that contains 5 and 3 does not fit into any one-dimensional set, right? Like a tuple of integers and integers does not fit into the set of integers because it's simply incompatible. This is very interesting. I feel like I'm getting somewhere. No, thank you. Mathematically speaking, is the set of if I have a product type of integer, is that a subcategory of integer? It's really hard to talk about category theory without, like, actually, like, damn. Integer x integer is a new object created by the product by functor. Right, so a product type is like a function, right? Like integer is just integer. But integer x integer is actually an integer, is a function that takes an integer and returns an integer. Integer is not a category, it's an object. But that's talking about, that's if you make integer an object, right? Because that can depend. If you mean subtype in type theory subobject, no. A subobject requires a monomorphism from the subobject to the base object. Yeah. So injection, injective, right? Injection means injective. Okay, I didn't make this a note apparently. It's a bit weird. Injective functions map every individual input to their own unique output. So there's nothing defined that maps integers to integers x integers, right? That is why they are not subtyped. They are not structurally or naturally subtypes of one another in standard type systems. Instead, they are related by projection morphisms. I see. So the bigger question really is, so in category theory, when are two objects or categories deemed incompatible? Yes, okay, I thought so. So it's not that incompatible, it's that there's no morphisms between them. There's no way to take A and get a B. right? And then you can change that by defining one, and then you've done it. So if you have two objects A and B in a category C, they're disconnected or structurally incompatible in a few ways. Oh, and categories have rules. Right. They have different structural identity. And missing limits. Okay. Unequivalent. Yeah. A partially ordered set as a category. So, okay, so then my question then is, if I have in programming, right, I have a product type. If I define a constructor that takes one thing, then the constructor is a function or a morphism, really. A morphism or a functor? Is morphism another word for a functor? I can't remember now. But, well, a morphism from the input to the output, where the output is a product type. But a product type is in of itself a morphism for two inputs to one output. Or rather, you can think of it as a morphism from one input, which is in itself a morphism. This is, yeah, I have to write this down. So now what I'm saying is, when it comes to morphisms, right? So a product type. So let's say I have a product type. Okay, well, let's say I have a constructor from int to int, right? Where this is a product type. Okay, so it's a tuple basically, or a struct with two elements. So this can be thought of as a morphism from int to int, or from int to int to int. We're in brackets here. So int to int to int. But I'm tempted to say it's to some like t. And so it's like this. I take my inputs, right? And then that constructs A, B, and together they form a single value AB, a single entity of sorts. Something like that. So then, this is based on like prior research, by the way. I'm not pulling this out of my ass, although I might be misremembering some things. So then, I mean, even if you look at Wikipedia, a coproduct. Well, a coproduct is a sum type. That's different. So let's look at a product, right? So a product of two objects. We can see this graph, right? F is a morphism. This is the product type. So what it does is it takes y, so one input y, right? And then you have some way to map or to morph y into x1 and y into x2, such that if you were to combine these, you get the product type x1 x2. Because if you can take y to that and y to that, then you get this. And likewise, you can decompose x1 and x2 into the constituents, which allows you to convert back to y. Is that even true though? I don't know. I don't know if that's true. So fix a category C. Let x1 and x2 be objects of C. So let's say my category is integers. Not even. Let's say my category is just types, okay? And then x1 and x2 are objects, which are integers. The types are integers, right? A product of x1 and x2 is an object x. So a product of x and x2, so integers and integers, is an object x, denoted as x1 cross x2. So notice how, because I have my two integers, they have formed a new type within C. I believe it's within C, which we will call our whatever. So again, suppose you have a constructor from int to a struct, which I'm going to call double int, okay? Or just dint, okay? So now this is equivalent to an int to a cross, because dint is just equal to a tuple of ints, right? A product of ints. Now a product type, but that's because dint equals int, right? But then an int is really a equals an int to some uniform type x, okay? To dint, let's say. Now, I know this seems like cyclical, so let me remove this. Like, this is the basic idea, right? I mean, dint and this are like really synonymous, but like the difference is that dint isn't equal to this. It's more like dint is no, it is equal to this. It's just like this is one type. Okay. This just helps you think of it as one thing, such that really that is an int to an int to an int to a dint. Okay. And now somehow we've gone from this to this, but it makes sense because you have this is a new type. Okay, it's a new type. We'll just call it x for simplicity's sake. Okay, we'll call it x. So our input x, constituent here, and then our product, like our result, which is x. That's how I understand that. So yeah, and it has a pair of morphisms, in this case pi1 and pi2, where you can get x back to x1 and x back to x2. Satisfying the following universal property. So for every object y and every pair of morphisms, f1 y to x1, f2 y to x2, there exists a unique morphism y to the product type, right? So if you can construct this from this and this from this, then you can construct that. Now whether a product exists may depend on C or on x1 and x2. If it does exist, it is unique up to canonical isomorphism. Because of the name of properties, so one may speak of the product. One may speak of the product. If it does exist, it's unique up to canonical isomorphism. This is the following meaning: if x prime is another product, there exists a unique isomorphism such that this equals this composed of this, and this equals this composed of this. Okay, sure. So basically what it's saying is that if there is a way, if there is a morphism Now isomorphism, I can't remember what that means exactly, but if there's a morphism such that you can go from X prime, which is in of itself a product type, to yeah, I think so. I think this is a product type. Then you have pi 1 composed with H will also give you the other thing. Whatever it is. Actually, I can't explain it. I think I get it, but I can't explain it. So maybe I don't get it. Now, then you have the co-product. Now, what's the difference here? The difference is that it's inverted. If I have the co-product type, x1, x2, which is it's like a sum, the sum type, right? An enum, then if I have so if there exist the morphisms x1 to the sum type and i2, sorry, if I have the morphisms that go from x1 to the sum type and x2 to the sum type of x1 and x2, then if I have y where I also have a morphism from x1 to that and x2 to that, then I can also go from the sum type to the y. Right, so in this case, if I have a sum type of integer and real number, let's say, then if I have a way to get, so if I have a way to convert an integer to an integer or real number, which I do, and a real number to a integer or real number, which I do, and I have a way to convert an integer to y and a real number to y, then I can convert, I say convert, it's a morphism. I can morph, I don't know, functiate, I don't know what the word is, bro, the sum type to y as well. Question is like, what could y be concretely? Okay, let's say that x1 is positive integers, x2 is negative integers. Right? I can map x1, the positive integers, to y, which is the real numbers. And likewise, I can also map whatever, x2, which is the negative integers, to y, which is real numbers, again. So if I have the coproduct, or the sum type, which is either a positive integer or a negative integer, then depending on whether it's positive or negative, it doesn't matter, I have some way to convert it to y ultimately, such that it is a real number. So I understand that. So that's helpful because I was trying to understand that previously. Now, how do I apply that here? Fucking hell. So, constraints. How do constraints work in category theory? Like, if I have the category integral, because again, like, I feel like there's some unification here that I'm missing that could like lead to some really cool way to do abstractions, or like powerful way to do abstractions. How do constraints work in category theory? In category theory, we don't enforce constraints by writing down conditional rules, validation, checks, or predicates. Instead, constraints are expressed entirely through structure and properties. If you want to constrain an object P to strictly represent the combination of two objects, it's a product. Okay, so you do this when you create a struct, right? If I create a struct, I'm constraining that if something is to belong to the struct, there must be a way to get from there to there, right? The weird thing about programming, though, is that it requires, like, you can have a struct that requires both arguments together, but not separately. So, like, you must have them together, you cannot have them separately. So I don't understand how that even translates to programming. I can have one value, right? One value map to two values. I can do that. And then that's a struct. Okay, I guess that's the idea then. Because two values as input is equivalent to like a morphism from one to the other, and yeah, I guess, I don't know. So okay, so one constraint. It's kind of interesting because a struct, like, you don't think of a struct as a constraint. You think of it as just a way to like represent multiple data together, like encapsulate data. But this is saying, well, just in general, in terms of category theory, though, a struct is a coproduct, and it is, you know, the constructor is the morphism that maps your input to the coproduct. And you know, if we just make it simple and treat the input as one object, you know, then yeah, it is a constraint. So then when I have a higher kinded type, like a type class, I mean, not really, but like if I have a type class, right, and I say it must implement add, then my constraint has additionally said there must be, well, no, it says there must be the morphism. So like, isn't that different? But the morphism what? I don't know. What else is there? Equalizers. If you want to constrain a system to only the parts where two parallel processes yield the exact same results, use an equalizer. Yeah, so I'm looking at constraints from I'm trying to link constraints in programming to category theory so that I can unify types and type classes. Yeah. So a prototype is like a tuple and bool, right? But type classes is predicate. So subcategories. To bring type classes into the mix, you have to talk about bounded polymorphism, like num a to a to a, right? Or like num a, or like where, whatever. A type class like num or eq acts as a filter of the entire category of types. It defines a full category num of type. The objects of CNUM are only the types that possess a valid instance of that class. The objects of category num are only the types that possess a valid instance of that class. Okay. But what is a valid instance? The morphisms are all the standard functions between those specific types. Okay. When you write a constraint function, so a function that says for all a, num a to a. Okay, you're structurally constraining the domain of your open type variable a to only exist within the specific category. Yeah. If you want to view types and type classes as the same mathematical substance, you shift your perspective from subcategories to monads and T algebras. This is where constraints and types completely blur together. A type class defines an abstract interface and a set of laws. In category theory, an interface plus its algebraic laws can be modeled as a monad T, and a concrete implementation, its instance, is a T algebra. So the functor or monad T defines the syntax or the operations allowed by the type class. Allowed. Not required, allowed. So for example, a monad representing a monoid interface might take a list of elements to be combined. The carrier object, this is your concrete type, interstring. The evaluation map. So TA to A. This is your type class instance. It is the actual function that takes the abstract operations, TA, and classes them down into a concrete result in your type A while respecting the laws. In this framework, a type constraint isn't a check performed by compiler checker. It is a requirement that a valid evaluation morphism H exists in the category of T algebras, the Eilenberg-Moore category. I'm exploring it from a syntax design point of view. Types whose values are functions. Of course. No, literally. But the functions aren't defined. Why functions? And like, not necessarily, right? Because you can inherit from a struct, but inherits data from it. Like, it must have this field, right? That's different from just it must have these functions. Like, if I have a player like let's say I have a player type class, right? Or like an entity type class, which I can like derive player, enemy, whatever. Like, and like I require that these entities must have an x and a y position, not as functions but as fields, like variables, right? Like struct members. That's different. That's different. I don't know. Yeah, ML and OCaml have. Is it first class? I mean, they have modules. I don't know if they're higher ordered modules though. In a language with first class modules, you can pass interfaces around, store them in data structures, or compute them at runtime. 1ML, functional language by Andrews, is a perfect example of this. It unifies the core language values and types with the module language into a single syntax. Is this the language? Is this Rust? I'm very confused. A function that takes a type, like why is it using Lua comments? It's kind of funky. A function that takes a type and its constraints as a single module package. Type T You can also pass an impl. Impl show t. Value x of type t. So here we are saying, yeah, I want a type t. I want this implementation of t. And I want this value. I mean, because value is of type t, that really seems quite redundant. What are dependent types? This seems promising. Although, what are dependent types? It rings a bell. What is 1ml? Andreas Rosberg. One ml. I have to read this. Holy rabbit hole, dude. 6 hours in. That's actually an interesting way of looking at it. There are things that can happen at runtime, and then types are your things that happen at compile time. But not necessarily, because type information can still exist at runtime. I don't know if that's true. Types can describe other types, like list t, but types cannot look at values. What does that mean? Dependent types completely tear down this firewall. They allow your types to literally depend on inspect and execute code using runtime values. This is not a... Is that not a product type? In a dependently typed syntax, the return type of a function can change depending on the exact value passed in as an input argument. Consider a function that creates an array of zeros. In standard language, you can't enforce the array size at the type level based on dynamic input. With dependent types, you can. Returns a vector of exactly length n. You can do this. Oh, but it's compile time. No, it's runtime, sorry. Yeah, so in C++, right, you can pass a size in your template parameter, but it must be known at compile time. You can't do it at runtime. But that's for a good reason, right? Unless you want to be like generating code at runtime, which you generally don't. I mean, you can. It's just not the most optimal to do, right? Okay, dependent pairs. It's not some types. I'm very confused right now. A standard tuple type, like in string, means you have an integer and a string. A dependent pair means the type of the second element in the tuple changes based on the value of the first element. Int monoid. Okay, again, I don't think this is particularly, like, I believe this is well supported by the languages I've used. So why this matters? Types become first class values. You don't need a special syntax for generics because types are just regular arguments passed into functions. This is what Zig does. For example, look at how clean a generic identity function becomes when types are just values. Function identity t type xt to t equals x. I want my thing to work. I want to explore syntax for defining types and type classes that is unified. A type that contains functions. Okay, so we listed this already. So struct monoid takes a type with empty, so these are functions, right? Empty A, combine A to A. So monoid is now a function at the type level. It takes an object A and returns a new object. I understand that, how monoid is a morphism. Struct monoid type A. So I can create a monoid of type int. And that'll give me a monoid int. But then I need to import it as well. And then I can pass around the implementation. Before we look at how to define a concrete instance or how the compiler passes it, how does this initial syntax look to you? It's fine, but I also want to compare it to how you'd define a regular type, such that, yeah. My examples were integral, addable. Right? Integral and addable. So an addable, yeah, it's like an addable U32. You would define the add function for U32. That makes sense. But integral, for the integral U32, it just is. That's what Rust does. Well, not necessarily. So for the integral U32, how would this work with the types, or with the structs integral, addable, and even integer? Yeah, what is an interface hierarchy? So addable is just an interface, right? It just says add. Integral, it misunderstood me. That's fine. I can put that. Even integer. Integral shouldn't be a collection of functions, but rather rules, rather a collection of possible subtypes, e.g. U32, U64, U16, U8, U32, I64, etc. And say I have a player struct that has both functions and data fields that is constructed as an object. How does that work in this system too? So what I'm getting from this is that constraints, when I define even integer, right, with this requires clause, it is on the type system level that says there is no morphism from x to an even integer if x is not divisible by 2, right? If x is not even. Right? Which makes sense. So then it's an invalid type, and you get a compile time type error. And if you want to prevent yourself from getting it, you need to prove that it is even. and you do that by error handling, right? By saying, fine, if it's not this, then I'll do this, otherwise then construct it. And it'll say, okay, well, if it errors, then I know it's that. If it's not this and I know that it errors, then you handle that. So in that case, I will accept it, and I will trust you now that this, I mean, not trust you, I know that this has to be an even value because we have already changed the path, right, if it is not. So that's the constraint. Like, it is literally that, like, in the type system. And it's as simple as that, right? Similar to how, like, when you like, let's say when I take user input, right, and I want to process it as an integer, I can't just say user input equals, you know, like, sorry, I can't say my integer equals the user's input, because the user's input is probably a string, and that is a type error. Before I can convert it to an integer, before I can accept it as an integer and like assign it to an integer, I need to convert it from an integer. I need to prove that I'm able to convert from a string to an integer and show that morphism. You know, like, show that morphism exists, essentially. If it doesn't exist, it will not compile, right? So you get a compile error. Not runtime error, compile error, okay? Same here. You get a compile error because like, it's possible, well, not impossible, like, there are values that simply do not map from X onto my even integer type. That is what's going on here, even, right? That's what's happening. There is no morphism, therefore it does not compile. I've seen other ideas of this where instead, like, at runtime, maybe you get an exception. So then you can try to construct an even integer, but then you get an exception. But that's not a type. That's just like having a type that throws exceptions. What you want is like a proper, strict, strong, compile time checked thing, right? That says, is there a morphism? Is there a way to construct my even integer from this type with no errors, right? Like, fully, like, perfectly covered, so it's safe, right? Like, it's like you don't want it to crash. And if the answer is no, then make sure it does by branching away if it doesn't. So, like, say if it's not an even integer, right? Like, you could literally create a static function or build in static functions into the type system that says, is valid even integer, and then if it's not, go down this branch and then do something else, handle the error, or if it is, then go down the path that says that, well, that constructs it, right? And that's fine. That's perfectly fine. That literally makes perfect sense. And it's at compile time, so there's no runtime performance. And it's completely safe, and it's because it's checked. It's type checked, right? So that seems really good. Now, well, why did I say that? I mean, that's what it is, right? Yeah, it's constrained. Okay, so then we have interfaces. An interface is a constraint, right? It is also part of the type system. It says this thing must have this method, this function, or else you cannot construct it, right? Like, this type requires this. If it doesn't have this, then there's no morphism from that thing to this type, because there's no, it doesn't implement this function, right? So, like, it doesn't fit my requirements, therefore the morphism doesn't exist. Same thing. It's just a question of how you write it, right? Like, here I said requires x is divisible by 2. So, like, when I say requires that, I don't know, requires that the function add exists, right? Requires a function. I guess so, right? Like, literally. And that's just for the constructor, by the way. That's only for the constructor. After that, everything else is free game, right? So, like, I can have as many struct members as I want, you know, but all the matches is that the constructor says, before you can convert to this type, you got to meet these requirements, or else the morphism doesn't exist. So that is the unification, right? So then you don't need type classes. You just have types, and types can have requirements, and types can accept different things. So, like, for an integral type, or no, let's say for an addable type, it must implement add, right? And then if I want to have another type, But here's the thing though, I want to have a type that derives from a different type, addable, a type that meets the constraints of addable. So I'd probably say that my type, let's say my type integer, requires addable, and then it just composes the requirements, and that's it, right? And then I don't need like traits, I don't need anything, like I just need structs that have a requires clause, and that would make sense. That I think that works. You're looking at integral as a sum type. Sure, but not really. So integral as a collection of types. It matches on this enum at compile time to know which concrete layout it is dealing with. Interesting. Very interesting. But then the thing is, the enums also need to be like unionable. Like the U8 isn't part of the integral enum. It's what the integral accepts a U8. But let me do that. So for player, you have ID, health, position, right? And then you have the functions. So take damage. The thing is, though, you would define it, right? Constructing the player object. So player equals this. Okay. Okay, so I think these are numbered, right? So for point 1, I don't mean a sum type per se. I don't mean that integral is either U8 or U16 or U32 ... What I mean is that integral accepts U8, U16, U32, etc. And only those, like a constraint. For point 2, what I'm getting at is that typically the player struct would already come with methods defined, with those functions like take damage and move to defined as part of the player type. It is only the the fields, the variables, the variable fields that get defined on construction in that case. So we have a mixing of predefined and later defined, right? That's why it's weird the struct doesn't have default arguments. Well, I mean default, well no, those are static, that's different actually, I guess. Got it. Let's adjust our mental model for both points and exactly what you're aiming for. It's like when you think about it, a function is, it's not static, but like, it is static. Because it's not specific to that instance. They're related to this, man. So integral as a constraint. If if integral is a type constraint that only accepts specific types, it acts as a compile time filter. Yeah. So you just say is integral and then it does this, right? So that's fine. Yeah. Proof is true is integral. TT. Sure. But I'd make it a bit more nice. So then the player struct, predefined behavior versus later defined data. We can set the states from the methods. Player state, method, and then player. So player state. But then if I want to do player dot state. Okay, I'm gonna think about this more when I go to pee. Okay, so at this point, I feel like Gemini has reached like his limit of usefulness. This language is very interesting. 301 stars, 8 commits, 8 years ago. Ah, yikes. Okay, so there are some other things I want to address. So I'm talking about variables and functions, right? But what is a variable? Right? Like first of all, we're assuming that functions and variables are different in the first place. Another issue I've been having with programming language design is getters and setters, right? You want to have an interface for your variables that isn't tedious. Like if I have to, because like if I have to wrap like my player's position, right, in a getter and a setter, then I also need to then I probably want to have like other things like change x, which is plus equals and like whatnot. But that's really tedious. It's really tedious. And then like I have to type get x or like get position as opposed to just like dot position, right? Like it's annoying, but at the same time it lets me restrict setting. It lets me restrict. It lets me to change the interface later in case I want to change the implementation. That's a big reason that in Java it is a common pattern to use setters and getters for absolutely everything, even if like it's completely redundant, just because of the possibility that in the future you might change the underlying implementation, and you don't want the user to have to update their, how they interact with it. So it's quite important. What's this? Oh, okay. Hold on. I'm actually reading this properly now. This is interesting. Shit. Is it like a spec? Maybe. Oh fuck! Is this a zip file? What? No, PDF. Okay, here. So reading this description here, right? It's saying that it's something that I also noticed when I use OCaml, is that you have modules, but you also have types and expressions, and it's like, okay, so let me finish my thought here. So the issues are, first of all, types and type classes. They're really weird, and I don't like how they're implemented in any language. For C++, you have interfaces, and therefore with Java and C#, they also inherited those that thing, right? That way of doing interfaces, and like virtual classes, abstract classes, like whatever, like inheritance, right? Inheritance. And you have issues when it comes to, like, if I want to have an even integer type, like I can, but first of all, constructors don't work properly. They don't like. Well, maybe with like some future version of C++, they could have like some way to like throw compile warnings, or like throw compile errors that like basically like throw exceptions that cause compile time errors basically, or maybe that's already possible. So that's one thing. The other thing is even if I have my even integer class, to access it as if it were a normal member, like a normal variable, is not really easy. And that's something that Bjorn Stroustrup, right, has talked about, how like he wishes that, or like he wanted to create a language where user defined types were indistinguishable from built-in types. and primitive types. Like, because like you just like types are types, right? Like if I create an even integer struct, it should not be absolute aids to then allow having, my x plus 2, right? Where x is my even integer instance, and I don't do x plus 2. Like, to do that, I then overload the operator x, and then probably overload plus equals, and then also overload minus and times and divide to have all the functionality of a normal integer. Like, it's just a pain in the ass, right? So what you want is like an alias, like in Haskell, or like a type def, right? But with constraints. That's basically what you want. So that's one thing. Other thing, variables and functions. So the whole getters and setters debate, as I've talked about. Again, in languages like C++ and Java, which have no like real good ways to do this, it's insufferable. I hate it, and it's why people usually still don't use getters and setters a lot of the time. It's just because, unless like they're writing enterprise software and like they have to as part of their job. But if you don't have to, you probably be lazy and not do it. And fair enough. C# has getters and setters, right? It has like specialized syntax for it, which is cool, but it means that you have these properties, right? And properties are the thing I don't like about them is that they're accessed like normal variables. So you think you're accessing variables when you're not. You're accessing functions, but they're disguised as variables, and that's weird because then you also have functions still, and it's like, okay, and then like if I have a private setter, then I can't set it, but I can still type it as if I can set it. So that's also really weird. With Rust, it is the same issue as C++. Rust doesn't really help that at all. With Haskell and stuff, you don't have variables, you just have functions, and you have structs, but you can't mutate anything anyway, so like you don't really have setters. So you just have getters, which is fine. I mean, like it works within that model, but obviously it's a pain in the ass then to do anything because you can't have mutation. But then you can have mutation in some extensions, or like some, like I think in Haskell you can have mutable things, but then that just opens the same issues that you had with C and C++ for structs. Or well, yeah, whatever. And then you have like Kotlin, which has getters and setters, I think, built in. So that's interesting, but I don't think it does anything particularly crazy, or else I would think I would have heard of it more by now, or like seen how it does it. It should have come up by now. And then the third issue, so to recap, number one, encapsulation wraps. So wrapping structs is annoying, right? Structs that wrap is annoying. You want to have things that you can access as if they were unwrapped. Number two, getters and setters, pain in the ass. Number three, modules. Modules and classes. Why are they different? In fact, Java literally restricts you to one class per file. So, and each file can also be compiled as a standalone component, right? Like if I have hello.java, which only, okay, maybe not. Like if I have, like, Java, I don't really understand how this has gone underappreciated. Java literally lets you compile each class as a standalone thing. Now, if it imports other things, then it will need those dependencies, right? Obviously. But like, once you have those dependencies solved, at any point, you can go into your Java project and just Java C any file that you want. Make sure you have its dependencies also compiled, right? But then that's it. It will just compile. And then you can run it. And then, well, if it has a main function, it'll run. If it doesn't, then I think you can target specific functions as well, which is also really cool that you can target specific functions. And I mean, that's largely due to the JVM. I don't know how you do that in like C++. You need to have like the type information, the function information and everything inside there. But the point is, it's modular, right? And each file is limited to one class or one public class, which means that you are forced to organize your code such that each file is its own class. Each file is like a module, right? Whereas in C++, there's no such. I mean, C++ there isn't a fucking module system anyway. In C#, you might have to, but I'm not sure you do. But C# is similar to Java in many ways anyway. In Rust, you don't have to. In Rust, you can have as many things as you want in one file, and therefore modules and classes, or rather modules and structs and implementations, impls are separate, and traits are separate. So this paper is interesting because it's talking about, in ML there are two languages, right? There is the core with types and expressions, and then there are the modules with your signatures, your structures, and your functors. Modules form a separate higher order functional language on top of the core. There are both practical and technical reasons for this stratification, yet it creates substantial duplication in syntax and semantics. It does. And it reduces expressiveness. For example, selecting a module cannot be made a dynamic decision. Language extensions allowing modules to be packaged up as first-class values have been proposed and implemented in different variations. However, they remedy expressiveness only to some extent, are syntactically cumbersome, and do not alleviate redundancy. Right? So what you want is a way to unite these things, which are literally, like, they're only different because someone couldn't think of a way to unify them. Or initially they thought, well, you know what? That's that. I don't see the connection between them. Right? So then they made them separate when they didn't need to be. And because they're separate, it creates limitations and incompatibility issues that shouldn't really be issues. So those are like the three things that stand out to me. The fact that, so like, these are things that are different when they shouldn't be different. User-defined types and primitive types, they should not be different. Like primitive types can be compiler defined, whatever, but whatever the point is, the interface should not be different. The interface should not be different, and it should not be cumbersome, to have it mimic the interface, because it shouldn't need to mimic it, it should just have it out of the box. Number one. Number two, variables and functions. Two things that, again, why are different? In functional programming, they aren't different. They're the same. In imperative programming, though, they are still different. Even though, like, a variable isn't even a variable. Like, what is a variable? A variable is a pointer into memory. Like it is an address with an identifier. And when you get its value, you are literally calling a getter to get the value at that address. When you set it, you are setting it. When you do the address of operator, right, the ampersand, you're getting the address of it as if it were a property of it, right? They can be treated like first of all, variables in themselves are structs in a way as well, to that extent, that contain functions. But my point is, like, they aren't. Like values are structs as well. You know what I mean? Like the only true primitive value are the ones and zeros, the bits of your system, and then everything around that is a wrapper over those bits, right? And then the third thing, like I said, is the modules and functions, or rather modules and classes, modules and structs, modules and classes, modules and whatever you use. Why are they different? Why are they different? Right? Why do I import a module? Right, and then I import classes from the module and like functions from the module, and like again, like also people complain about Java having everything be object oriented, so like everything is a class. You can't have a standalone main function. Honestly, that's a good thing because it makes it clear that you have the global namespace, which is not global. It's just like it's just a class that you can call global. Like everything lives in some kind of world anyway. Like if I create a simulation inside the real world is still, potentially a simulation. You just don't necessarily know it from the inside. Like, and that's, I don't know why that was the example I thought of. But from that point, right, from that point of view, for that reasoning, like in C++, you have the global namespace, right, which is a namespace. If you create another namespace inside the namespace, like, just because you can create namespaces does not mean you do not live in a namespace, right? Because you have your main function does not mean that your C++ program is not technically inside the main class. And the good thing about Java is that because it is, it forces you to do that, it means that you can also create multiple instances of your program very easily. Whereas in C++, you need to use, I guess, like threading or like spawn multiple instances of your executable once you compile it. And these are frictions that don't need to be frictions if you just treat things as they are, right? Rather than ignoring things and making them different even though they're not different. Because when you make things different when they aren't different, you're compromising. Like, right, you are probably eliminating features from at least one of them to then make them different, right? So that one is a more limited form of the other, and then therefore one is an inferior form of the other. And therefore you have limitations in your language that frustrate programmers because they want to be able to do things that are like, more high level, but they can't because you've restricted them for reasons that don't have to be restricted, right? So there are other examples, by the way, like I created a list of them. Even I made a thing called code versus machine. I don't know. Okay, actually, I made a shit ton of things. Holy moly. And for this, the aim of this, like, I guess, project, you could call it that, was to look at the ways in which a computer treats machine code versus how a programmer treats their human code, right? To think of ways like, okay, like, what things are being changed from how they actually work under the hood to, to the human side in ways that may be unnecessarily limiting, right? So for instance, variables, right? As I said, like, a variable is an address with, like, it is a named address. So for example, when you create a reference, right, a reference variable to another variable, all you're really doing is creating, like, a named address that has the same address. So, like, it's just an alias, right? Like, if I have int a equals 5 and int reference b equals a, then they both point to the same data. If I mutate a and b, the same thing happens. If I get the value from a and b, the same thing happens. So, like, why are they different? They are literally the exact same. A equals b, right? Like, the only way they don't equal b is just because I have two different labels for it. Like, the labels are different, sure. The accessors are different, but, like, the actual underlying data is the same. But then it's weird, like, because then, like, if a goes out of scope, that it gets, I guess, like, deconstructed, right? And then b becomes an invalid reference, right? A dangling reference, which is problematic. But then, like, why is that even possible in the first place? To create a dangling reference, like, can we think of a way in which that isn't possible, where, like, you literally cannot create a dangling reference? Like you have the stack and stuff, but, like, it shouldn't be possible to do that. Like, I shouldn't be allowed to create a reference to a variable that is in a different scope that will go out of scope before me, because then it's not, like, I'm pointing to data that shouldn't be there. And, like, pointers are different. Also, pointers and references, like, references are essentially just syntactic sugar for pointers, except references aren't nullable. Except they are nullable because, again, they can be left dangling, in which case they become nullable. So, like, and, like, mostly it's just a syntax thing. Constants on computers, like, this read-only memory is not actually read-only. If you want to, you could crack it and mod your application, or, like, mod someone else's application, get on Cheat Engine and change these read-only values. Really, it's just an abstraction for compiler optimizations. So, like, it knows that, okay, fine, because this value isn't going to change, I can compile, I can optimize around this, right? And that's fine, by the way. But, like, it's calling it const, like, calling it immutable, when it's not so much immutable as it is you are not going to mutate it. I know that sounds weird, but, like, from one perspective, you are saying this data is immutable, it cannot change, right? That's not true. It is simply a promise to the compiler. It's not true. It could change. You could have some, like, external API call that violates that, and, like, nothing's going to stop it. Or someone could monitor your program and do something. All it is a promise to the compiler saying, okay, I will not mutate it. At least I will not mutate it in a way that you can detect. So it's effectively immutable, but, like, it's just the way you think about it that may have implications on how you go around designing the language. I don't know. Types. Yeah, I mean, like, types are also, like, compiler thing, right? Like, at runtime, you don't really have types. The difference between a float and an integer is literally nothing. Like, a type in machine code is defined by, well, the size, for starters, and then also the operations that can happen on it. But that's it. Like, if I have a char, which is like an unsigned 32-bit Unicode value, right, as, like, an integer, then, I can call a U32 machine code operation on it, and it will work, because, again, it's just bits, right? It is a construct of the compiler. So does that mean that we should get rid of types? Obviously not. But, like, thinking of types less as something actually happening in your program, and, like, more as a way to model your program. You know, like model it on like an abstract level. Because like with C, you have your different types, and that's more so like the compiler knows which, or like at least originally, like so the compiler knew which instructions to use, right? But like, there's so much more you can do with types, and none of it even like maps onto machine code anyway. It's like, yeah, it's just compiler. I don't know. So that was another observation anyway. I mean, like, not all these observations have like concrete conclusions, but it's just things I'm noticing that make me think about the ways that I think about programming in general, right? And the ways I think about programming languages, and how the syntax could just better reflect what's actually going on, right? Like when I declare something mutable, I'm not saying it can be mutated. I'm saying that I intend to mutate it to the like, and I'm telling the compiler I intend to mutate it. That's what I'm saying, right? And like most people know this, right? But like it's just making it very clear. Yeah, like I said, points of reference. There's actually no difference really. Moves, move semantics, right? Like when you move something, I don't know why it's called moving. You like moving is literally copying. Like if I move, well, I mean at least for the instruction set, right? Like for Intel, whatever. If you do the mov operation to move something, it copies it. And then if I move something in memory, which is the high level construct, and this is different, where it doesn't create a copy, what happens is that I pass ownership. So like I'm saying that, you know, like where before I had this variable, right, which is again a named address for this data here. If I move it, I am moving that address to another thing, so then that thing owns it, and then that thing controls the scope. So then we talk about scope. You know, when things are to be destructed, right? And then you know that based on ownership, an ownership model, right? If I am pointing to memory that I don't own, I should probably be careful because that memory could get deleted, right? In the same way that if I don't know, like if I'm watching Netflix on someone's account that I don't own, that person could just stop paying for their account and suddenly I don't have access to Netflix anymore, right? But I think I do because I've no way to know until I log into Netflix and I'm like, oh, that's not right. For instance, I don't know. Well, as opposed to like if I own the Netflix, then I control when I pay for it. I control all this stuff. I control when the account gets terminated. But my friend can just terminate it for me, you know. So like it's that kind of thing. And again, it's a construct, and then you can have shared immutable states. So then we can both have access to the account. But then because of that, if one of us deletes it, we should notify the other person so they also know that it's been deleted. Or one of us can delete it and then leave the other dangling, and then that's, you know, that can happen to both of us. So then we have to trust, like, you know, like this, it's a real thing, real in our minds anyway. But like it's real to think about. Freeing memory. Yeah, when memory is freed, like it's not really freed. It's worse. It's that you lose track of it. And then because you lose track of it, the OS says, okay, I guess you don't care about this anymore, so I can overwrite it when I feel like it, you know, and so it does that. But like ultimately, when you delete something, it's actually deleted. It's more just giving back control to the OS that says, by the way, I'm done with this, so feel free to overwrite it or leave it. I don't care, or maybe you do care, in which case maybe you should zero it out. You know, like these are things as well. Arrays. Arrays are literally just a point, like an array is like a variable, except it just repeats contiguously. So if I have a pointer to the start of an array, it's like anything else, just that I can increment the pointer to get to different points of the array. So like really it's just contiguous values. And like an array doesn't have to be one type either. Like I can have an array that changes type, but that really just comes down to, again, optimization. Having an array be one type makes things more efficient because I can, like, you know, because like the pointers are a fixed size. I can repeat the same operations multiple times, so I'm able to optimize some ways to compute multiple steps of an operation at once, you know, things like that. Whereas if I have different types, then I can't necessarily do that. But then like if I'm using different types anyway, then I don't need the performance. But like I don't know, like why do arrays have to be a fixed type? In some languages they aren't fixed types. In some languages they can be a tagged union or a non-tagged union. I don't know. Or they can, I mean, can they vary in size? Maybe not. Because that'll kind of defeat the whole point of like contiguous and like indexed access. But conditional statements. Yeah, like you have jumps, right, under the hood, whereas in high-level programming languages, jumps are literally demonized. They say don't use goto unless you're using C because C is such a primitive language anyway. But otherwise, don't use goto, don't use goto. But it's like, okay, Shiza. I mean, like your functions are now your go-tos because they jump, right? But like your functions are limited because, for example, a function can't return from the parent function, unless the parent function specifically checks for whether it should return from that child function. Like, you know what I mean? Loops are interesting because a loop like this, right, from I equals 0 to 10 would probably be reversed so that it goes from 10 downwards, because it's just, I don't know, because like it can use the jump if 0 instruction, so it makes it more efficient, right? But in high level code, you don't even think about that, right? Like, so when you say for I 0, and then go up until I is less than 10, with I plus plus each step, like that's a lie. Which is why I sympathize with instead having a for range loop, which is like for I in 0 to 10, because then you're saying that. But then it's like, okay, well then like does order matter? Because like then it's better to create loops in which order doesn't matter, and like that's a thing I also need to consider. But then like, how do I design a language that encourages me to do things in which order doesn't matter, right? Functions. Yeah, like functions are also not. I mean, similar to variables, functions are a like a location, right? Like, but rather than like jumping to data and an address, you're jumping to instructions. In fact, instructions and data are the same as well. Like it's kind of the whole point of like the von Neumann model or whatever, where literally data and instructions are the same thing. They're both encoded in binary and they're both stored in the RAM. So like, I don't know, recursion sucks. Floating point numbers can have different encodings. There's IEEE 754, but this has issues that people notice. Like the whole reason that Rust has partial EQ is literally because of this fucking convention, and like how like nan is not equal to nan, right? And like how you have infinities and like negative and positive 0. Structs. Yeah, the way you lay out a struct is not necessarily indicative of how it will actually be represented in memory, unless you force it to be. But typically, you'd want the compiler to change it, because like the order at which things appear can change. Like you may think that, okay, I have a unit 16, a unit 32, and a unit 8, right? So that'd be 8 bits plus 16 bits plus 32 bits. So that's what, 24, 56 bits, right? So divided by 8, you get what, 7 bytes. Like you would think it's 7 bytes, but it's not. It's 12 bytes because of padding, but the padding is completely invisible to you. You have to kind of infer it, and like you obviously can get good at inferring it, but ideally you'd want your compiler to reorder your struct members so that they are more efficient. So then you don't have to worry about efficiency. You just have to worry about what makes sense to you logically. Like, okay, like what, like abstractly what order makes sense, as opposed to what makes sense for the compiler to do. So like, if you were to reorder these, so instead of 1632.8, you have 16.832, or alternatively you could also have 32.16.8. Then you get to 8 bytes instead, right? You literally saved 4 entire bytes of memory. You have saved what, a quarter of the memory, or I guess in this case you've reduced it by a quarter of its original size. So like it's pretty, no, not even a third. Yeah, a third, which is obviously very significant. Enums are just labeled integers. So tagged unions are different, right? Null. Like, what the fuck is null? Like, null is zero, or is null like nil? It's not like an uninitialized state. Typically we don't like having null, but I don't know. Like, I I guess the issue with null is that like null is not type specific. So like null for a float could in theory equal null for an integer, when really you want to have like an integer null, where null is just an alias for a empty state, right? Like a way to represent nothing, right? So like nothing for an integer would probably be zero, right? Like if I say I have an empty integer, I'll probably say I have zero, right? Or if I have an empty string, I just have a null terminator, I guess. If it's null terminated, or a string with size zero, right? Whatever. So then I can check like string dot is empty. I can check if my integer is zero, but maybe zero is a valid state. I don't know. Like let's say I have age, right? Age as a variable. But then if my age can be zero. I can be 0 years old and instead be like 2 months old, right? So then how do I say that I have no age? Well, I can't say zero. I mean you can, but I mean like no age at all. Like age is not a concept that I am familiar with. So like in that sense, I want to have like an option instead, like an option int. So then it's a sum type. It's either an integer and it's tagged. So it's either an integer or it's nothing, right? And then that nothing would just be a state in the tagged union. And again, there are ways to optimize this on the compiler. Maybe use an age that isn't possible, like use like 9,000 as an age, right, to mean nothing. But from a high level construct, from a high level abstraction, you don't want to worry about that. You just want to do option to say that this is this, right? So then have those features. Expressions, yeah, things that seem like they're computed in one instruction can in fact be computed in multiple, right? Like 2 plus 5 times 3 is not one instruction, it would be at least 2. Not to mention that if I have like 7 times 9 plus 5 times 3, then it's even possible that the 2 multiplications will be computed in parallel, like literally in parallel, like on multi-cores, because I can compute 2 of them at the same time, and because the order doesn't matter there, right? But again, you, the programmer, don't really care about that. That's more of a compiler thing to worry about. But the language needs to be designed, again, like for all these things, the language syntax needs to be designed in such a way that the compiler can make these optimizations, and the human can still understand the code. Order of execution. Yeah, I mean that's why, like multi-threading and like just general order of execution is where not having mutability can be useful, because although there is mutation happening under the hood, because you are not mutating things yourself, the compiler can choose when to do mutation, and then it can make more efficient decisions, right? Or more optimal decisions, whether it be for performance or maybe for, I don't know, to like prevent data races, or what's the term? I can't remember. Like race exceptions, function overloading. Your humble print t will actually compile down to like print u32 and print string and whatnot in machine code. Like, there are different functions. Dynamic dispatch. Yeah, there's a vtable that's hidden to the programmer. In C, you have to program this yourself, but in other languages you don't, because it's just done for you at the compiler. So anyway, these are just some things. And so when I look at these, I think of ways to unify. Another one was if statements and pattern matching. I don't like how match is a separate keyword from if. I think you can handle pattern matching with the if statement by having like the is operator. The only issue is exhaustiveness. You need to have some way that's not cumbersome to have exhaustiveness. So that's one thing. But like I just think of things that like seem similar in any, well, in a programming language that you like, let's say, or that you don't like, and just like think of ways like, why is this different? Like, why are function parameters, like, why is function parameter syntax different from struct syntax, right? Like, technically the function parameters list is a struct. It's just an unnamed struct, right? And for some reason it doesn't have named arguments, so it's like called like a tuple in many languages. But like, why are tuples different from structs? Like, why, like in Rust, why do tuples use parentheses but structs use curly brackets, even though they are the same thing, just that a tuple, sorry, has unnamed fields, and like that's pretty much the only difference. I don't know. Why? I don't know. Like why? Like vectors and arrays. One is static. One is boxed. Right. One is heap allocated. You can have vectors of a static size, right? So then it can shrink and grow within a certain size. And in C++, you literally have standard in place vector, right? As of C++ 20, I think, which is literally a vector that can be array that can be stack allocated because it has a fixed upper limit. You know, and that's pretty cool. You know, and like, should we do that for more things too? Like, if we know that there's an upper limit to our game, then should we impose that and have it be stack allocated instead? Maybe, probably. I mean, to my understanding as well, like with heap memory, your stack can effectively grow as much as the heap can grow. So like, I don't think there's limits to how big the stack can get. Such that if you can allocate on the stack, you should. And the only times you wouldn't is if you have dynamic memory, or if you have memory that can be reallocated, or that may need to be reallocated, or you have memory that needs to outlive its scope. But that can still be done on the stack by just creating the variable outside of that scope, right? Or like assigning to it outside of the scope. Anyway, just yeah, there's a lot, and there's more. There's way more. So these are the issues I want to tackle in my language here, right? Like standard IO, like the standard namespace could literally just be a struct called standard that contains, right, other structs like IO. And then, but like, it's static. Like I could do this in C++, right? And then I would literally be able to do standard IO, right? And then I'd have struct vector, right? I mean, it'd be class for whatever, but right? And then boom, I have a vector. Okay, maybe not IO vector, but like print line, let's say. But like that would be a function, right? So I have a function print line. You know? So like if I can do that, why do I have namespace? You know? And like namespaces can also have global functions. So like why? What's the point? Like there's literally no point. It doesn't make sense. So for my language, I'd want to not have modules. I'd want to have instead a way to nest types, right? And like, do I impose the same rule as Java, where you have one type per, or like one class per file? Well, maybe not. At least like with Java, you can have private classes in the same file. It's only the public ones, right? Because the public ones are the ones that you can interface with. So I don't know. And like, how much code fragmentation do you want? Like, how many files do you want that have like 3 lines in it? But like, should we split files based on how long they are, or should we split files based on, you know, what they represent, like literally what they contain? It's a question, you know. So yeah, so I'm going to end this recording now. Actually, am I? No, I'm not. I want to do some more things. So first of all, let me just check Portugal versus Spain again. Spain won. Ooh. In the 91st minute. Goodbye, Ronaldo. Spain have not conceded a goal this World Cup. Well, neither did Mexico, but here we are. That's crazy. So what's the bracket? Spain against the US or Belgium. And then we have Norway versus England, And then these two guys are yet to play. So this is tomorrow. Okay, Argentina at 5. Okay. I don't know if I'll watch any of these. This is tonight. USA, Belgium. I do want to be there for France, Morocco, but I also have a job interview the next day, so. Okay, can I just see the upcoming ones like this? Yeah. Exciting. So I want to give this a proper read at some point. Let me go back to this. I'm kind of bored of this now, to be fair. Let's just kind of like skim through it, have a look. So, type annotations, right? I32, you can apply it to a thing here. Either one works. Again, I don't like how there are two ways to do things, but okay. Int type, int a, okay. I don't know why it has to be int a. Float type, yeah, floating types. Okay, anonymous struct types. Okay, ownership, borrowing, it's ref, borrow sets. Okay. Distributability, right, this was like the main point, wasn't it? Yeah. Let me just look at the table of contents. Implicits. I don't understand why you'd have implicits. That's weird. Okay, then abilities are the main thing here, right? So okay. I'm kind of lost at this point. Right, resume. Right, so resume literally just resumes it. Okay. So save div, classic example. Fail is implicit for some reason. If b equals 0, then fail. A over b. Sure. Just not a fan of how it's not particularly clear that this doesn't continue execution. Fail, resume, fn, unit to never. What is never? Does never just like does nothing. Throw resume function e to never. I mean, I get it. It's just like I don't understand why you would use this, because like exceptions are still not the nicest thing. So like it's why I don't really get effect systems, like why we would want to use them. I get it for like making it explicit what it might do, but like this is specifically for how it will error. But result types solve that issue. Okay. Have to get rid of this. So what is function coloring? I still don't get that. Well, so like some functions may return result types, others may use exceptions, and therefore you have just issues in how you call them. Okay, I guess. Yes, a problem. Which is why you should ideally only have one way of error handling, not multiple, or else you're going to have people just having incompatible, or like at least have compatible ways of error handling, such that you don't have to like have different ways of handling it for each one. Like you just use like the same, like the interface is the same, if that makes sense. But I don't know. I don't know why effects solve that at all. It just means that you're only using effects, not really that you are solving the coloring problem. Okay, dependency injection. Business logic and database. Or can programmers just name something like logically for once in their lives? I feel like this is just misusing the feature. Like, why would you have a database be an effect? Why would you not have like a database handler function or struct or something and use that instead? I mean, I get that. Also, effect? I thought it was abilities. Or are those different? Is this different? Is this outdated? I don't know, man. I get their traits. It's just the fact that the effect or like ability idea doesn't like like translate to everything. Like it's not quite. It's not quite as all encompassing as a different word could be, or whatever, a different model. Okay. Okay, in this case, why is get not just generic? Like a gettable trait. I mean, even in general, like if all functions derive from a trait, right? Like all of them. Like if I want to have a move function for like moving a player, it better derive from the movable class or something. But then like what if I have the same word that means different things in different contexts? What do I do then? these are ideas for the language, right? Okay. Well, that was Ante. Yeah, so I'm going to continue with this. I just want to end this recording because it's like 7:30. Actually, it's almost midnight as well, so I might just go to sleep at this point. But I will come back to this because I wanna keep on doing this because I do want to build my own programming language, but I can't implement something that isn't designed yet, so I'm going to design it. There you go. So yeah, that was interesting. 7 hours and a half is actually crazy. What the hell? I don't know how I do it. Just checking Discord real quick. No new messages there in the programming language server. Yeah, so Ante is a language. Effect-based programming, I still don't really see the point. Like, okay, if it does I/O, I don't really care. Like, if it does I/O and it can error, then I'll just know it can error based on what like errors it can return from the function. That's kind of the whole point of a result type, right? So yeah, I'm not sure what else to say about that really. That's just kind of how exceptions work, and I don't want exceptions, so I'm not going to use effect program. I generally don't understand why this has become all the rage when result types are literally like existing. Yeah. Anything else to say about the language even? I mean, I wish I had more positive things to say, but literally all my notes are just like negatives. I mean, it has some cool things. Like, it has piping, just not piping in the way I like. So sue me, I guess. It has a double modular operator, which means it's divisible by, which is cool. I don't know if I'd add it, but it's a thing, right? Yeah, and then for the stuff that I covered for my language ideas, right? I think there's something cooking there. I think there's something promising. So yeah, wow. I don't know what I'll call this video, but it has been a video. Thanks for watching. Subscribe for more videos on programming language design and yeah, I mean, at this point really I don't want to do anything until I have a language I like using. Like, I like programming, I like making applications, but I don't like programming when I can't program well, you know? And right now I feel really limited by the languages by the languages I'm using, and I feel like I'm doing lots of tedious things that I don't want to be doing. So until I have a language I actually like to use, like, extensively, it's going to be difficult for me to really do much programming. So I'm going to program a new language. That's my goal right now. Once I do that, I will have a much easier time doing literally everything else, and a more fun time probably, because I'll also be using a language that I made, I guess. So even if no one else uses the language in the entire world, at least I can get some good use out of it. Question is just how long will it take to implement it? So subscribe to watch that journey. Peace out.